We can start? Okay, cool. All right, folks. If you're a builder, I promise this will be the best 20 minutes of your next 3 days, because we've worked with over 150 startups in the last 3 years, many of which are the who's who of crypto at the earliest stage. So we learned a lot of lessons, and we're going to distill all these lessons with you in the next 20 minutes. So we've worked with, for example, Synthetics, 0x, Kyber, Tensor, Stepan at the earliest stage. And of course, many failures. And so we're going to share some of the key ingredients for success and failures with you guys in the next 20 minutes. So we're going to talk about today how to find a winning idea and also a winning team in crypto. So myself, Imran, we're partners at Alliance Style. We'll be giving a presentation for about 5 minutes each. So how to find the winning idea in crypto. One of the best ways to build a winning idea, to find a winning idea in crypto, is to build something that you yourself want to use. And that should be fairly intuitive. I'll explain why that's the case. Because, and this is not really unique to crypto, by the way. Building a startup is almost like finding a secret. And it takes a long time to find that secret. It takes a lot of really good intuition into the market that you're operating in. And guess what? If you are the user of your own product, you're going to have the best intuition about the market that you're operating in. Fairly intuitive. I'll give you an example. Tensor, which is now the #1 NFT marketplace on Solana. We supported them at the earliest stage. Those guys, when they applied to Alliance Style, they were building something completely different. They were building some random NFT pricing protocol. Obviously, we knew it was not going to work. But these guys have been in Solana NFTs for 2 years before they applied. And so they were degens themselves. They were NFT traders themselves. So eventually, they had this idea of building an NFT marketplace for pro traders, such as themselves. And every time I talk to them, every time they talk to us about a new feature, a new product idea, it's always about, oh, would I want to use this myself? And that's always one of the really great ways, likely ways for you to find a good idea. And this is not just unique to crypto. It's everywhere in startups. So that's one. The second way to build, to find a winning idea in crypto. And unfortunately, this is going to sound pretty discouraging, because the way to find winning ideas is to be in this space for long enough of time and really focus on the space full-time, day in, day out, for a long period of time. And that usually takes 1 to 2 years at least. And why is that the case? Well, that is the case because crypto is such a counterintuitive space, right? I'll give you some of the things in crypto that are counterintuitive, that even Web2 people don't really appreciate. So for example, in crypto, if you build decentralized applications, you're not supposed to move fast and break things, because crypto handles money. So if you move fast and break things, you can lose for good. You're going to lose your reputation for good. So that's one of the counterintuitive things that crypto is about. So, and it takes a long time to appreciate these things. So being in crypto for long enough of a time will help. Unfortunately, a lot of founders coming from Web2, especially in the bear market, they pivot back into Web2, including AI or whatever the latest hype cycle is. They pivot back right before the critical juncture of that 1 or 2 years, right before the time they find that secret that I was talking about. And you don't want to do that. You want to stick to crypto for at least enough time for you to develop the intuition. The next way to find a winning idea is to explore the intersection of your previous domain of expertise and crypto. This one should be also fairly intuitive. Helium is a very good example. If you guys know Helium, that's the decentralized HubSpot network. And the founder, Amir, he spent almost a decade in network engineering. And at some point, he was like, maybe I can apply the idea of Bitcoin, this decentralized compute, using tokens to incentivize people to participate in the network. And so that's how he figured out the idea or the original idea of Helium. And so if you come from, for example, I don't know, imaging, like aerial imaging, right, like drones or whatever, you can think about maybe using drones to capture images in a decentralized network and build some sort of Google Earth kind of product, for example. Think about some of the ways in which crypto could potentially help with your existing domain of expertise. So these are some of the ways to find winning ideas. Now, what are some of the ways not to find winning ideas? And this will sound really controversial. Talking to users is actually usually not the way to find the winning idea. I'm not saying you should not talk to users. Talking to users is absolutely critical. But some of the best ideas I've seen, they always organically come from their intuition. Intuition is where the best ideas come from, almost all the time. You should talk to users once you have the product out and learn why people do or do not use the product. Again, this touches on the 3 points that I brought up before, especially the second point of being in crypto for a long time and develop the intuition. So talking to users counterintuitively is usually, of course, there's always exceptions, but usually it's not the best way where the best ideas come about. And the next one is reading theses that VCs put out. Some of you are laughing because you do that. I can tell you do that. And I'll tell you why this is not a good idea. There's a couple of reasons. One is every time you read a thesis that VCs put out, chances are, especially the super famous popular VCs on crypto Twitter, chances are 10,000 other people read the same thing. And I know this for a fact because every time someone, I don't know, Kyle Samani or Paradigm or whatever, every time they put out a thesis, we receive a bunch of applications to Alliance DAO that are building the exact same thing. And this is a really bad idea because if you just decide to build something because VCs think it's a good idea, you don't fully understand. Again, like you don't have the intuition, the deep intuition as to why this product matters. And you're competing with 10,000 other applications. And this is why it's not a good idea to read, to use VCs, what VCs put out on Twitter as the key determining factor for why you want to build a product. So very straightforward. I'll pass it over to Imran to talk about how to find the best teammates to work together on.
Hi, guys. So the next 5 to 10 minutes, I'm going to help you think about how to find the right co-founder or to hire your first employee in your company. But primarily, this is about finding your first co-founder. And the reason why I think this is important is because primarily in hackathons, when people are meeting with others just to figure out an idea, they typically may have no idea that they may have a lightning in the bottle moment. And when they do, then that co-founder is the co-founder for the rest of your life, right? So what I want you to do is to, within the next 5 to 10 minutes, I'm going to help you assess who is going to be the best team member for you to work with for the next 10 years. And the first is the why, the what, and synergy. Can you align on ideas quickly is like the #1 example. Like if you were to meet with someone and you're ideating on a certain idea that you want to hack on, are you able to ideate smoothly with the person that you're talking to? Can you support each other through stress? So an example of this is being able to understand if not, they can help you with the stress and the situations that you can go through. And number 3 is high agency. Does that person that you're working with have high agency? Can they take on tasks and know that they can fulfill those tasks? So those are some of the things that I would look for when you're looking for a person that you want to hack with. And so sometimes when we get applications within Alliance, we see solo founders that apply. And there's nothing wrong with solo founders. There's many successful solo founders that have succeeded. But an interesting story I want to bring up to you was the story of Paul Graham at YC and Drew Houston of Dropbox. Drew Houston actually applied to YC 2 times and he was denied. And the reason why he was denied to the program was the fact that he was just a solo co-founder. And Drew asked Paul, like, why can't I just build this idea that I had, which was Dropbox at the time. And Paul Graham specifically said, you need moral support and you need someone that can have synergistic value so that you can focus on one area of growth while the other person can focus on the other. Similar with Coinbase, you had Fred and Brian and others in the space. You need moral support, you need someone that can understand you, and you need someone that can help ideate throughout the process. And so when you think about looking for a co-founder or a hacker, what are the things that you'd want to look for? Well, there's 2 ways that you can go about it. The first way is, are you a domain expert yourself? Do you have a secret that no one else does about the expertise that you have? A clear example is what Chao just said earlier with the intersection of domain expertise and crypto. If you have that domain expertise, then you may want someone that can help you with business and growth. Let's say you are a business and growth lead, then maybe you'd want someone that has a very deep technical background or a secret that they know that can help support the project that you're working on. And I think this is a very clear, important message I want to give you guys is that you have to do this early on, because if you don't, then there is going to be a lot of overlap and then stress, and then it could lead to things that you don't want it to go through. So finding that early on is going to be very, very important for you. 2 is, and I think this is the second reason why most founders break up very early on, is the fact that stress is a very, it's going to happen, right? You're going to work 80 to 100 hours a week. And stress is going to ultimately make or break a startup. That's hands down. And so what you want to look for when you're looking through, the folks that are in this room or outside this room is, can they deal with stress? Do they have high emotional intelligence or EQ? And the reason why I'm bringing all this up is because eventually, towards the end of this presentation, I'm going to give you a 5-minute test that you could take and use this test to find others and ask specific questions within 5 minutes to find out if they're a good match for you or not. So there's a reason for the whole, some of the questions I'm bringing up here. The third is, do they complement you? Because as I've mentioned earlier, is let's just say that you have 2 technical folks that are co-founders. The biggest problem that I see here is the different unique insights and advantages that they have when it comes to building product. And one co-founder could have a very specific tech stack that they want to work with, and that's all they want to work with. And I've seen many hackers early on that kind of fight, and they end up not delivering a product or even an MVP after the hackathon is done. So it's important to really figure out if that person that you're hacking with is going to be aligned in the vision, and are they able to complement you in regards to where you're going to go next. So here's a quick 5-minute test, the questions I ask. And in fact, it turns out these questions is how the Tensor team got started. And the Tensor team, if you know, is the #1 NFT marketplace in Solana. And the way they found each other was through this test. I gave you a minimal version because this is good for just a hackathon. But for a real startup, there is a longer list that I can share with you guys later. But I'm going to go through this quickly. Some are obvious, so I'm not going to go through it, but some aren't. One question I want to bring up is, are you control or wealth oriented? I think this is important because some co-founders want control. Some just care about money and they want to help build the product to a certain point and allow the actual founder that wants to lead to take leadership and run with it. It's much easier to find this out early on because you know who's going to run what, and usually it turns out to be a good decision. And the reason why I bring this up is because many co-founders, you'll notice this, like, you know, in mid of growth, you'll see like co-founders kind of fighting with each other. One wants to be the CEO, the other wants to be CEO. Then you see this co-CEO role that kind of is given, and it's usually a red flag when you see a co-CEO role. So that's why I was kind of bearish on Salesforce. So that's one question. The second question that I want to highlight is, like if you are like really serious about starting a startup, like if you're here to start a startup, you know, the one question you want to ask is, where is the priority of starting a startup in your life, right? Is it your number one priority? Is it number three? You're just here to hack and have fun, make friends. You could quickly figure out like who's going to align with you and who's not. So I'd say that's a number two important question. And some of the other questions are, you know, a little bit more detailed, but like, what are the things that are important to you? Like, what type of product do you like? You know, what type of culture do you like? Types of folks that you want to hire. Another question I want to point out is like, what happens if we make no money in 12 months? And then finally, here's a second set of questions. If you're to pick one thing, what is your superpower? I think this is another good question that you should ask someone. What role do you have envisioned for me? How do you deal with stress? What is your biggest weakness? And at the end of the project, you should kind of like decompress and ask questions in terms of like, did you guys enjoy working with each other? Did you see eye to eye? Did the ideas that were generated really come to fruition? And so these are like the set of questions that you should ask when you're looking for someone, because this will kind of like boil it down to the people that you really want to align with, so that you can start a startup or build an idea here at ETHGlobal and then be able to work on a winning startup idea moving forward. If you have any questions, you can find us at the Alliance booth, but yeah, thank you for coming.
That should be, yeah. They have not projected it yet?
Yeah.
Oh, okay, cool.
Great. Hey.
I'm Alex, I'm the sound guy.
Awesome.
Can I just keep a bit of space on the mic so that we don't hear your breath?
Is this good? Or...
Go a little further.
Oh, great.
Yeah. And if you turn your head, it's a little wider.
Oh, yeah. Awesome. Thank you. Great. Will they signal me? Yeah. Hey, welcome everyone. Yeah, we're going to get started with the workshop. Just want to first give a brief overview of what Axiom is, and then talk through how you can actually build a ZK-powered app with Axiom in about 30 minutes. So first of all, what's the problem that we're trying to solve at Axiom? It starts with the observation that if you're building a smart contract on Ethereum today, you actually quickly realize that your contract can't access much data. As an example, if you look at the OpenSea listing page for Pudgy Penguin, you'll notice that almost all of the information that is on the page is on-chain data, for example, the transaction history or historic owners, but only the current owner is actually accessible on-chain. And the reason for that is to maintain the decentralization of transaction validation on Ethereum. So developers work around this by making pretty difficult trade-offs today between paying more to access more data in their smart contracts by just storing more data in storage, or reducing the security of their applications by using a trusted oracle that simply puts data on-chain. And so at Axiom, we're removing this trade-off by providing a new way to access historic on-chain data using zero-knowledge proofs. What that means is that we use the fact that the current block of Ethereum commits to all historic data on Ethereum to give cryptographic proofs that a piece of historic data that your application is using is actually valid in the history of Ethereum. So because we're using cryptography instead of consensus to access data, we can offer a whole new set of capabilities for your application. And so we've wrapped this up into what we're calling a ZK coprocessor for Ethereum. The flow of using it is that you send a query to our smart contract. We provide trustless reads to any block header, any account, or any contract storage variable in the history of Ethereum. And we're also adding transactions and receipts in our V2, which we're previewing at ETHGlobal. Once you have that data, you can do computations on top of it with custom ZK circuits and get to a result that your on-chain application is interested in. We provide a zero-knowledge proof that those results are actually correctly computed and come from data which actually comes from Ethereum. So that means that you can rely on data results that come from Axiom with the same cryptographic guarantees as something you're accessing directly on-chain. So let me talk through how you'd actually use this in your application. So the flow of an application that uses Axiom to access historic data goes as follows. First, we provide a very easy SDK to allow your users to prove computations and request data in your web front end. So here, we actually provide a client-side ZK prover that your users are going to be running on their laptops. They'll send a query for on-chain data to the Axiom smart contract, which we're indexing. And we'll prove that the data access that they're doing is authentic using zero-knowledge proofs. Finally, we verify the end results on-chain with a ZK proof, and we execute a custom callback on your smart contract, which is the only change you need to make to your contract to integrate Axiom. So let me talk through the steps of actually integrating Axiom into your application. First, we've provided an easy web REPL interface for you to specify the computations you want to do and the on-chain data access you want to make. So this is called Axiom REPL, and we'll walk through it later in this workshop. Once you've done that, we allow you to export a WebAssembly ZK prover to a Next.js app. We have a scaffold app for you already from this web REPL, but you can also migrate that prover to a web front end of your choice. This would be ultimately what your end user is using to interact with Axiom. Once that's done, in the flow of your application, users would send queries to Axiom from the web front end. That happens through an on-chain transaction. We're indexing those queries, and we'll prove valid data access through zero-knowledge proofs that are executed on our server backend. Finally, we'll implement a callback you'll implement a callback on your on-chain application. And what we ask is that you extend our Axiom v2 client interface. That gives a standardized format for the callback, which allows you to check various properties of the query, make sure things are authenticated and permissioned correctly, and finally gives you the user data that you're actually interested in. Okay, so now time for a demo. You can follow along by going to repl-preview.axiom.xyz. It unfortunately will not work on your phone, but for those of you with laptops, you can watch what I'm doing. You'll actually see the same demo code as I'm running live. So let me just pause for like 5 seconds so everyone can get the URL, and then I'll go to do some live coding. All right, so back to Axiom REPL. All right, so what's going on here? We've developed a JavaScript interface to allow you to actually access on-chain data and do computations on it. So as you can see here, we have this in this window, you are writing actual JavaScript. And we're going to write an application to prove the first block that a user's account actually made a transaction on Ethereum. So how can we know that a user's account made a transaction for the first time at a certain block? Well, if you look into the details of the EVM, you'll know that we have to check that the nonce of that account was 0 at the previous block and then became positive on the claimed block where they made the first transaction. And that's exactly what we're going to check in this JavaScript interface. So we have an input box, which let me just pull up here. And what we'll check is that for this address, the first block in which you made a transaction was the claimed block number here. And this is all on Goerli testnet. So the way we do that is first, we compute the previous block. And here, whenever we do any computations in this JavaScript interface, we require you to use our JavaScript functions. We've written custom functions, for example, sub, add, mul, and div, to implement arithmetic operations that will later be proved in zero knowledge. So here we would compute the previous block number, and then we would call functions that we've implemented to allow you to access on-chain data through this interface. For example, here we're calling getAccount. You can also call functions like getStorage, getSolidity mapping, getTransaction, or getReceipt to access the entirety of Ethereum execution layer data. So here we get the account object from the previous block with this address, and then we can access the nonce from that account just by calling .nonce. And remember, we wanted to check that that nonce was 0. So we call assert equal to check that the nonce at the previous block was actually equal to a constant, which is 0. Now we want to check that at the claim block, this nonce actually became positive. So again, we fetch the nonce by fetching the account and then calling .nonce on that account. And then we use a function check less than to check that 0 was less than the current nonce, thereby showing that it's actually positive. So if all of these pass, then we can use a final function, add to callback, to specify that the address in the claim block number should actually be sent to your smart contract as the callback arguments. So if I click test circuit, we're going to generate test outputs here. And we'll see that indeed, we outputted the address and the claimed block number as the test callback arguments. Now I'm going to show a demo flow of this actually interacting with a contract on Goerli testnet. So to do that, we're going to generate proving and verification keys. And then we're finally going to generate a zero-knowledge proof of the execution of these computations, namely subtracting 1 from the claimed block number and checking the equality of the nonce to 0 and the positivity of the next nonce. Once we've generated this proof, we now can send a query to Axiom to authenticate all the data inputs that went into this proof. What I mean by that is we need to check that the account nonce that we fetched was actually correct for both the previous block and the next block. So we can do that by sending a query on-chain to Axiom. And that actually sends an on-chain transaction on Gurley. Once we send that, we can check it out on EtherScan. As you can see, it's still being indexed. So let me pull up a transaction I sent maybe 1 hour ago. So that's the exact same transaction. And we called this send query function. What we sent, and that's being done in our web front end, is some information about the data that we wanted to fetch. So here we have the source chain. In this case, the source chain ID is 5, which corresponds to Gurley testnet. The data query hash, which is a hash that specifies that we wanted to fetch the nonce of one account and at one block, and the nonce of that same account in the next block. And finally, the information about the computation we did, which we encode in this compute query object. So we have 2 pieces of information. One is a V key that allows us to verify that the zero-knowledge proof we did in the browser was correct. And secondly, the compute proof, which actually is the proof. So what this query is going to do is to request Axiom to check 2 things. 1, that the compute proof was correct, and 2, that the data we're requesting was actually used correctly in that compute proof. Once that check has passed, we're going to call this callback that you can specify. Here I've specified address of an example contract, a function selector of an example callback call, and we specified that 2 results should be passed, so there's a result len of 2. And finally, we allow you to pass in extra data in the callback as well. The rest of the arguments specify what sort of gas requirements you want us to hit the callback with. So this is a transaction that's been sent to the Axiom smart contract on-chain. And we will fulfill that request by calling the fulfill query function. As you can see, the fulfill query function gives you the compute results. So this was the address, and this was the block number that the address first sent a transaction. It also provides a zero-knowledge proof that the compute proof was correct, that the data was validly plugged into the compute, and that everything really came from the history of Ethereum. And finally, we hit a callback on an example contract in this case, but in an application, this would be your contract. And we require that you implement an interface for we call Axiom v2 client that simply takes a callback that expects the following arguments that kind of correspond to your query. So the first argument is just the source chain ID, where the data is coming from. The second argument, caller address, is the EOA address that initiated the query. So if you're allowing any user to send a query into Axiom for your application, this would be the address of your user. Finally, the query schema specifies what your query is about. So every time we write a query in the browser, it generates a unique query schema that you should validate in your application. The last 2 arguments, the query hash is a unique identifier for the specific query that's being sent, and the Axiom results are the results. In this case, the address and the number and the block number where that address first sent a transaction. So all you need to do to integrate Axiom into your application is to write a query in our Axiom REPL interface, export the Next.js prover, and then implement this Axiom v2 callback function on your smart contract application. And we provide this interface, Axiom v2 client, for you to do it. OK, so the last couple minutes, just wanted to reiterate those steps. So first, you write a query or circuit in Axiom REPL to specify the computation, export the prover, modify your front end to integrate that prover. We will, on our server, index your user's queries and approve valid data access. And then you will implement a callback on your contract. So for this weekend, we stood up a preview version of Axiom v2 on Gurley. And we have a bunch of ideas for what you can build with it. First, we think the areas of identity and governance are super interesting. We think you can provide autonomous airdrops, namely airdrops where you deploy a smart contract with some criteria for who should be able to get the airdrop. Users can prove using Axiom that they performed relevant activities in the past and are therefore entitled to get incentivized. That takes away control of the airdrop from a centralized team and gives it to a smart contract. Similarly, you can imagine giving volume rebates or other types of loyalty rewards for usage of on-chain applications. If you think about Uniswap, no matter how much you trade, you're paying the same fee. With Axiom and Uniswap v4 hooks, you might imagine that higher volume traders or new traders can get lower fees. Another angle is that you can actually construct a trustless oracle using Axiom. You might imagine taking an average of on-chain gas prices and constructing an index of Ethereum gas prices to settle a derivatives protocol. We listed a few other DeFi ideas here, and we're having special prizes for the best usage of Axiom in both identity, incentivization, and oracles. And DeFi. In the last couple minutes, just a couple more ideas. You can use Axiom to slash participants in a protocol on-chain. For example, because we allow you to access transaction and receipt data, we think you might be able to detect whether an Ethereum block contains a sandwich attack and who might be responsible for that. If someone's responsible for a sandwich attack, maybe you should punish them. Or maybe you can use that attack to refund part of the proceeds to the initial user. Other things we think are interesting are automatically adjusting parameters of a DeFi protocol using on-chain historic data, or having batch auction settlement prove to be optimal, again, off-chain. Finally, there are a bunch of very silly ideas. You can give people little badges for various on-chain degen activities they may have done. Imagine proving that you owned a lot of one type of NFT, or you lost money trading NFTs. Imagine you have a badge if you lost 100 ETH trading NFT. You could also prove that you did various interesting on-chain activities. For example, if you farmed YAM during DeFi summer, I think that might be a notable attribute of your account. So we really are interested in creative ideas from you guys. We also have a special prize for the most creative usage of Axiom, as well as the best overall usage. So we have a bunch of materials prepared for the ETHGlobal Hackathon. We have a special guide at ethglobal.axiom.xyz. And if you use this QR code, it'll take you to our Telegram group where you can get help directly from the team. That's it, and I think we have maybe 1 minute for questions. Yep.
So is it right that user can kind of decode the memory hashes to understand what the protocol is very?
Yeah, the question is can the users decode the query hashes to understand what people are querying? And the answer is sort of. The query hash commits to the query, but it doesn't reveal the information of what's in the query. So that's actually sent separately on-chain. Any other questions? In the front?
Real quick, just making sure here. Is there any sort of like application protocol interface for this, basically? Would that be in the docs, I assume?
Yes. We have a full TypeScript SDK. And actually, we export a sample Next.js app from Axiom REPL that uses that SDK.
And as well, are you guys using any sort of like web clients for all this, or just a regular? I'm just making sure here.
Yeah. So all the proving for the front end can be done just on the client side. So no special stuff on the web client side.
Okay.
Thanks. And we have a booth out in the booth area. So if you have further questions, you can come find us there.
Okay, man, thanks. That's cool. Displays. Arrange. Wait, where's mirror? How do you do mirror? Where's mirror? watch out. It has an edge there.
Yes, the station, if you're two people here, be careful. And we're clearly not trained to set up this, but glad it's up. So good afternoon, everyone. Thank you for coming to the workshop on NextID with Mask Network. My name is Hannah. I'm one of the co-founders of NextID and head of global growth at Mask. And today we'll have David here leading our developer relations, talking more about how to take reputation everywhere with decentralized identity and universal profiles. And we'll definitely talk more about, for this hackathon, some of the exciting things we want to build with all of y'all. So without further ado, David, take it away.
All right. So, as much as I love fragmented attention, we're going to do a quick exercise that will make this really a lot more fun. And it's a repeat after me. Good. Now that I have your attention, we are taking reputation anywhere and everywhere. We have cool pictures to tell you who we are, because just in case we're faking our identities, you need to know that at least we are cool. So there we are. We're going to jump straight in and cover a quick context of what has identity been in the past, what is it today, and where is it going in the future, and why does all the stuff that we do really, really matter in a deeply important way for that. Traditionally, identity looks like credentials that allow us to do things like get mortgages or go to bars. They come from a central issuer, and they're super, super useful and powerful for us. But today, the world is transitioning bit by bit and slowly and all at once from analog to digital. And so we see that represented in a few metrics. 8% more time year over year has been spent every year for the last 20 years online. So we start to think like we have these really useful identities for the the analog world that go with us when we go to a new place. But how does that look online? How do we have the identities that we can control and identities that we can take with us to different parts of the internet? So a lot of people ask, is a wallet an identity? The answer is actually no. It's an identifier. It's like an email address. It's something that represents a way that someone can find you. And so what we look at is like, how do we combine identifiers traditionally in Web3, identifiers in Web 2, such as Twitter handles and email or YouTube channels or whatever you want, and all of the data and reputation that you've built. How do we package that into identity that you can bring with you to any place in any ecosystem? And the whole point of all this is our identities today in the real world are sovereign, portable, and relatively secure. But a wallet address doesn't really pass that test because it can't really go outside of a single chain ecosystem usually. So we're going to look at how do we solve that? How do we move forward? It's going to be cool. So we think of identity as a sum of the identifiers of the person that represents who you are. So this would be it could be an Ethereum address linked to your Twitter, linked to your Facebook, to some sort of business page that you have. And one of the cool concepts about this is when you have a universal identity graph, when you go to a new place, if you as a dev are like, hey, I wonder if this user has an identity or has a footprint, right? Are they a real person or a real enough person? What information did they bring with them that is useful, right? Can I instantly personalize an experience in my DApp or in my app because now I know their Ethereum history, their Solana history, the amount of Twitter, the type of their Twitter footprint, and all of that. So it's kind of cool, and we'll spend a little more time on that, and hopefully have a couple of light bulb moments for you all. But we do this. We bind these identifiers together with something called DIDs. Sometimes people say, "Oh, DID, decentralized identifier." Almost. DID is a decentralized or a decentralized identity. Almost. It's a decentralized identifier. And it actually is something that we call an avatar, but it's a key pair. And a key pair is used to sign proving ownership of your different identifiers to create and knit this identity graph. So you see your avatar is your key pair, and you're signing, you're using signatures to record a record of I own this Ethereum address, I own this Twitter account. And these get stored in a public database on Arweave, or you can get them from us through our APIs. We focus primarily on data that is public. So a lot of times we talk a lot about privacy as a sector. And there is a ton of information that should be below the privacy waterline of the iceberg. Really important. However, there's also a lot of identity and reputation that is above that waterline. And that's most of what we focus on currently today. So the public-facing things of what matters about you. We have 3 primary parts of our services. So one is using is a service called Proof Service to create the bonds between these DIDs that constitute your reputation or your identity. And then we also have basically a way to query those or to get those, get all the DIDs called Relation Service. And then we have a really, really nice new SDK that makes working with these things super, super easy. And it makes querying or updating what you call an identity graph or a universal profile really, really easy. So I'm going to jump into this really quick. So one way that this can look that is pretty cool, as you see here, we have for a single user, all of the different profiles or identifiers about a person displayed in one place. So if you as a dev want this information to make your profiles super, super rich in whatever you're building, this is how you do that. If you want to have the reputation or accolades that somebody builds in your ecosystem, in your game, or in your DeFi battlefield, if you anchor these actions to a DID with our services, that means people can care, or people can take this reputation that they've built in your product with them everywhere that they want to go online. So a little bit of a different paradigm and a little bit more portability than we might be used to ecosystem to ecosystem, but it's that same magic moment that we all felt the first time that we used a DeFi dApp. When we logged in and we signed in with our wallet, and then all of our information was just there. That's what we want to create beyond financial use cases using the same cryptographic primitives. And we are going to be at our booth, and we'll be able to answer all these questions because it can be a little tricky. The SDKs make it a lot easier. It's actually pretty darn cool. Hannah, you want to jump in? Cool. Come on out. You want this one?
You covered this part already, the APIs.
And now Hannah will talk to you a bit about bounties and past winning projects and a little bit about what we're looking for this week.
Yes, thank you, David. I'm going to start lowering this microphone because I'm very much buried. I'm a short person. Great, so you've seen a lot of these demo of how Web3 Bio would look like, and our SDK for developers to build on. And for the past year and so, we've been running NextID to understand how to better serve our developers and help you build the next really exciting applications around social or gaming. So, I think this is. Do you see it? My slides are gone for some reason. Do you see it? That's okay. I think we can.
One moment, technical difficulty.
Yes.
But we will pull it back in about 30 seconds. So there we go.
Yeah, go on, mate.
You saw it in the previously, right? Do you not see it now? All good. You know what? We can go to ETHGlobal's website. Yeah. And if you want to just...
Just start talking.
Yes. All right. So we have about 3 minutes, and I'll quickly go through what people have built in ETHGlobal Paris in the past and what we're looking to build with you all for this hackathon. So in ETHGlobal Paris, we've seen a lot of exciting projects utilizing both our proof service and a relation service, which is our universal profile SDK. So what 2 projects have built called, one's called Graph ID, another one is called Data for Builders. Essentially, they read into NextID's relation service and are able to help builders build up their very credible user profiles that has their GitHub, Lens profile, Farcaster on top of like other like credential or like a newsfeed. So it really serves as the identity underlying like a layer for people to get onboarded and start creating their profiles that's suitable for Web3 use cases. And for proof service, we have actually one project called Builder Garden. They're a crowdsourcing project. Yeah, wait. Wow, I'm so big on the screen. Builder Garden, so they're a crowdsourcing platform allowing people to fundraise to attend expensive crypto events and hackathons around the world, and to verify that you are a real hacker and you have these identities. You can see here they integrated with the proof service, with our proof service. So users, after they onboard and create an DID, they will send a message on Twitter verifying who they are on Twitter. And thank you so much, David, for rescuing me with this tech glitch. Yes. And for data for builders, you can see the workflow here. So after users, usually like you can create a connect to wallet flow and then read into NextID's relation service that will be able to pull through with one identifier multiple profiles, and then you can build more like recommendation feed, et cetera, on top of it. And now, so this time, this time for New York, we're continuing the bounty around building cool applications and use cases around our universal profile SDK and our relation service. So if you want to like build applications that allows for a cross-platform search, and and recommendations, or developing the next generation analytics, user analytics that helps projects identify where their potential users are the most active. Are they Twitter degens? Are they like opinion leaders on Farcaster or Lens? You can read into use our universal profiles to build that. And a new one that we're really excited about is a specific identity solution for. So this is the visualization of how our identity graph will look like. And if you want to go back to the new bounty, a lot of us through the booth have already asked us about account abstraction and how they can integrate some of our like identity graph or DID into the account abstraction design. So we do identify a particular use case around on-chain gaming, but not limited to on-chain gaming, and then the potential developments you can do or to work with like account abstraction and DID through that lens. So the different challenges that we see in on-chain gaming today, there's a lot of latency and also disconnection between different parts of the games in autonomous world. So how to have like a more unified, seamless onboarding system for the gamers and allow their reputations and credibility to be carried across different parts of the autonomous world. That is a big challenge, and it's our first time testing out this bounty. So definitely welcome a lot of the feedback and see, besides gaming, what are some of the other use cases you may be interested in building out this infrastructure. So that will be it. We are right on time, and if you have any questions, we're happy to address it offline here, and also we'll be at the booth the whole day. Scan into our QR code there, we'll have cool swags, and also our dev will be on office hours for the entirety of today and tomorrow. Thank you so much.
How's everybody doing today? Are we off to a good start? Perfect. All right, so hey, I'm Carl Fluke. I am a solutions architect and starting to do DevRel for Coinbase, specifically focusing on our new L2 OP stack base. So today we're going to just run through a super quick all about that base, kind of some of the tools and partner ecosystem we've built up, and then what bounty overview are we doing and what do we recommend that people build during this hackathon. So just curious, for a show of hands, like how many people like participated in On-Chain Summer and did something with Base so far? Did anybody? Good amount. Awesome. Cool. Has anybody actually deployed something on Base yet? Just one? Okay. All right. Well, we're going to change that this week or weekend. Okay. So a lot of people have heard Coinbase. Kind of the internal joke for the actual Base team is we're kind of like the biggest off-chain L2. We have 120 billion some assets, all of them are off-chain, and we slowly want to start pushing all of that consumer and institutional assets to be on-chain so that we can actually use them in DeFi and start to go even further into crypto. So our big motto for Base for probably the next year or two is on-chain is the next online. So I don't want to like overkill this, but like before the internet, we had Blockbuster Video. I'd actually go to the store, I'd get my Xbox or GameCube game, and that was old school, and now that's gone. Physical has slowly moved to digital. Now we have the internet, it's super fast, we have things like Netflix, but kind of the 2000s to 2020, it was very much so that these Web2 companies now control your content. You have the ability to read and write, but at the end of the day, that ownership is with Google, it's with AWS. They have the ability to turn it off. And so now here we are, blockchain technologies are actually, you have digital ownership, and we can start to recreate all these Web2 tools to actually be permissionless. A big part of that is that I think crypto focused on infrastructure for the past couple years, and now we have a whole bunch of kind of building blocks we can use. And a big part of that is now we need more developers to understand them and use them to build actual consumer products. So our kind of thesis is we've been slowly growing on-chain users. With more users means that there's more developers that can build tools for them. There's more actual users that you can use to grow your protocol. So some example use cases here. We have Farcaster for social media. Local to New York, there's Blackbird, which is starting to do some like restaurant loyalty programs. So you can imagine that's a combination of tokens and NFTs. And then a good partner, Parallel, they have a trading card game that I like a lot, but starting to do some of that GameFi on-chain. So as we have developers, they start to expand these use cases that we can provide, and then ultimately that means that transactions will continue to grow on-chain. Here, the blue line is Ethereum. It's been more or less at capacity since 2020. And so now these L2 rollups are starting to come out and take over that actual transaction volume. But unfortunately, there's only 10 million people on chain so far. And we have 8 billion in the world. So we've got a long way to go. And our thesis is that we can slowly start to expand that pie. So kind of just super quick history. Coinbase, central exchange, started with Bitcoin. Started to do a ton more assets. Our first kind of like on-chain activity was USDC, partnership with Circle. Now that USDC is on multiple blockchains. Moving into DeFi, like Coinbase Wallet was our first true like crypto product, non-custodial wallet. It enabled us to actually go into the DeFi ecosystem. And then that's kind of continued. And so now we have our L2 base. And so here we say we're like maybe 10% on chain, maybe it's closer to 5, but over the next 5 years, how do we switch that to be 100% on chain? Okay, so a lot of people have already used Base, so I'll kind of quickly go over this. We chose the OP stack mostly because it's MIT licensed. Coinbase is the second core contributor to the Optimism Collective and like the OP stack. So all of our contributions are open source. We actually directly are part of that code base. So as more OP stacks come in, we're in partnership with them. The main thing that we're focused on is I'm super looking forward to 4844, hopefully coming out later this year. That would get us super close to 1 cent per transaction. It's probably 8 to 11 cents today, but we think that there's a lot of unlocks that happen once we actually get to a 1 cent transaction. We kind of have a company goal if we want to be able to do transactions in 1 second under 1 cent, and that's kind of like the 2-year journey that Coinbase wants to move, is being able to give users that. So as I said, Base is the second core contributor to the OP stack, MIT licensed. 15% of all revenues from the sequencer fees we actually give directly back to the OP collective, and that helps fund their public goods funding. So we're super happy to be part of that and help expand the open source and slowly keep helping Optimism move to be decentralized. Okay, so as a bunch of you guys are already well aware of Base, we had our on-chain summer. It's been open for 7 weeks now, 8 weeks. So excited to get more people building on it. There's actually a ton of dApps out there today. We did a pretty good job on getting the ecosystem on board. Definitely a long way to go to get more tools. If we're missing anything in our ecosystem, please let us know. We're always looking to expand partnerships. So yeah, so far today, we've actually already bridged 145,000 ETH. It's gone pretty well. And then our transaction volume has surpassed Ethereum for pretty consistently for a month or so. We're also the fastest L2 to actually get 100,000 users. So that's kind of the main thing that Base can bring is we have around 100 million, a little over 100 million KYC'd users on the exchange. And how do we slowly push them to actually being on-chain? We have a ton of users that bought Bitcoin, they bought ETH, they kind of get it, but they haven't done on-chain stuff. So how do we make good user experiences for them to move into this new world? So high level, like the main thing that we wanted to build Base for was we wanted to have a tool out there that we could start to move a lot of our products on-chain. We started as a very centralized company, and so slow and steady, we will start to rebuild some of our internal products to be just completely on-chain by default. So there's lots of examples here. And it goes across both actually our consumer-facing products and our institutional. You got the full list here. Gives you kind of like a good spread of where we're heading. So I want to go over just some like the tools available to you. If you're a developer, a lot of these will be familiar, but we also have some net new ones that are kind of specific to the OP superchain. So I think EtherScan is probably going to be the best well-known here. We have our own version. It's called BaseScan. With that, just for pure redundancy, we have a second version for Block Scout. It's very familiar. But then these other three you may not be as aware of. Route Scan or SuperScan is actually a OP superchain explorer. So it'll actually show like Base, Optimism, Mainnet, Zora network, public goods network, all side by side. So being able to do a better job of like putting L2 blocks side by side in the OP superchain. And then Dexguru and Tenderly both have a little bit different focus, kind of based on use case. Node providers, we have a ton. Everybody needs an RPC endpoint. So a lot of these you are probably familiar with. I do think Alchemy recently launched, so they are on here now. So easy for this. If anybody has any questions about node providers or if we're missing one that you like, come talk to us. Oracles, so I think Chainlink and Pyth probably have the most feeds. That's just if you need off-chain data and use it into your product. They have a ton of feeds available. Redstone is fairly new. They're starting to spin up more feeds. And then Supra launched their verifiable random function. So if you need random numbers, that's available on Base now. Data indexers, I know that a couple of these are here. These are the big three. If you need to do Graph API of on-chain data or have it indexed in a custom way, it's available to you. Cross-chain messaging. So Axelar with Squid Router, Layer 0 with Stargate, and then Wormhole. So if you want to do bridging in between other L2s or do cross-chain messaging, we are focusing on kind of like Base is a bridge, not an island. So we do want to work with all the L2s and make it so that they're interoperable for like DAOs, for actual just bridging of assets for doing DeFi. So very much so we are in it for the ecosystem and for furthering Ethereum. And some of these tools help further that mission. Okay, so most of you guys are devs here. Tool chains, very basic. RIP to Truffle, if anybody saw the tweet yesterday or the day before, they did say they're going to close down in 90 days. But if you're familiar with EVM, very basic build, deploy, test. And then clients, same, work with Ethers, work with Web3. One newer kind of client to the game. Has anybody used VM yet? A little bit? All right. So that's a newer client. It's just much more type friendly. I've been growing as a fan of it. Okay, so for support for this hackathon, we do have our own base Discord. We kind of break it down into infra, developer, smart contract, front end. So if you want support, it will be there. We also will be on the ETHGlobal Discord. Okay, so for our actual bounties here. So build a consumer product. So kind of Coinbase's like a short motto is the most trusted, the most secure, easiest to use. So that's kind of how Coinbase has grown to where it is focusing on those three tenets. And in line with that, like build a consumer product truly is like make it easy to use. So we want to see like very creative consumer products. So like we're not trying to go after just another financial use case. We want to see something that's like a consumer could use, they could understand it. It's not confusing. So we gave just a few examples here. Use account abstraction, make subscriptions easier, do something with ticketing, show kind of some benefits of like what being on-chain means and how that's more visible and helpful. Second big bounty is just do a creative NFT project. So we wanted to be vague on this on purpose, just so that you can be creative and fit kind of with what you want to build. So examples here are like we had on-chain summer. We had a ton of users go through and mint different NFT collections. Like what could you find out from that activity? Another account abstraction kind of idea, but how could you combine paymasters with NFT activity to actually choose, do I pay for gas for somebody or not? And some novel ways of doing that. Onboarding 6551 wallets. So if anybody has a good use case for actually using like the NFT wallet, and for a loyalty program, I don't want to be very prescriptive with use case, but just creative use of it. And then lastly, how do you combine like NFTs with attestations? Ethereum attestation service went live on Base 2 weeks ago, and it's just a way to be able to attest on a custom schema that somebody did something or has something. Okay, so before I do Q&A, I just want to show one fun project that I've been a fan of. So this is called Base Paint. And so this was just a project that every day people agree on a theme. People can come in and do 1 pixel. So did anybody take place in like the Reddit art place? A few people. So it's kind of like a different idea of that, is that every day you have pixel artists. They can do many pixels based on a time frame. After 24 hours, it gets snapshotted, and people can mint those NFTs. So yesterday, apparently the theme was Lens. So here's a Lens Garden custom art piece. You can mint it. They're not very expensive. And then after that 24 hours, the open edition ends. And my favorite part is that the amount of ETH that was collected. So in this example, Lens Garden yesterday has had 1,400-ish mints so far. That was 3.4 ETH. And what they do is actually take that ETH income that they had and they redistribute it to the pixel artist. So 645 artists got some amount of that 3.4 ETH. So just a very creative, consumer-friendly way of, hey, let's get people to collectively make an art piece. Let's mint it and let's redistribute those funds back to the artists. With that, does anybody have any questions? Yeah.
In regards to mobile developers, what sort of documentation can you provide in regards to stuff like React Native or just some sort of like API stuff for Base models?
Yeah, so base.org is our main website, and under here, docs, it kind of has like the high levels of what all of our actual ecosystem partners have. But if you're kind of new to Solidity or smart contracts, Basecamp is a pretty well formulated walkthrough of all these kind of like what are ERC20 tokens, what is a lot of the basics of these. And we do have like NFT badges once you get through certain sections. So this is always my starting point.
Okay, and I assume there's no sort of like, is there any sort of like SDKs for Base, or I'm just making sure here.
Yeah, so the question was, are there any other like SDKs for Base? So essentially, the OP stack is EVM equivalent.
Okay.
So anything that almost anything that works on just L1 Ethereum, you should be able to use directly in place with Base. You would just switch out your RPC endpoints to point to the correct chain ID and the correct RPC node.
Great. Sounds good. Thank you.
Yeah.
Yeah, for doubts, I'm not sure if you have moved outside. I don't think so. I didn't see it. You recommend I go directly to the Discord. Yeah, just for doubts or questions with the hackathon.
Yeah, so the question was, where can you guys seek out help? In the ETHGlobal Discord, we should have a partner Coinbase channel. And so we have a few people remotely that will be monitoring that. And then we're more than happy to like jump on Google Meet or Discord video. Cool. Yeah. Then I think we got 2 minutes ahead of schedule. Thank you all.
Hey, everybody. All right, so I am John with UMA, and I'm here to talk about one of our newer products that we came out with this year called OSNAP, which you can use to actually decentralize your DAO, and then also talk about how you can modify it for some really cool hackathon projects that use natural language rules. So a problem that a lot of DAOs have is that they're voting on snapshot, and then they have a multi-sig that actually executes the transactions on chain. So you have this point of weird centralization where you had a whole bunch of people come together to vote, but then what actually happens is controlled by just a handful of people that have these admin permissions. And a lot of DAOs realize that that's a big problem. So OSNAP's been really popular, especially with DeFi protocols, and I'll go through some examples and explain how it works. So first off, UMA is an optimistic oracle. And the way that that basically works is you can bring any kind of data on chain. You're saying this statement is true, and also here's a bond, take my money if the statement is wrong. And there's a challenge window where anybody can show up and they have that financial incentive to dispute you if you are wrong. So there are people that are watching these proposals 24/7 looking for disputable proposals. There's also a lot of very bot-driven flows for some of the products that are built on top of UMA. And it makes it super flexible because you could have things that are human reviewable, you could have things that are bot reviewable, and you can build all kinds of products with it. So what it can actually do, a lot of people think about oracles as being this price feed style thing where you have a network of nodes that have to reach consensus on some data before pushing it on chain. But what it really is like a truth machine. You're trying to record some truths about the world onto blockchains, and the optimistic oracle mechanism makes it really flexible to record basically any kind of truth as long as it's publicly verifiable. And we kind of like walk through that. One thing I didn't mention is it adds some recourse to contracts. A lot of the issues that come up with oracles are if like the data is wrong, that a bunch of nodes came to consensus on some data that is wrong in some way, that could cause a lot of damage to a protocol. With an optimistic oracle, you don't have that kind of issue. Like if you are dealing with price data, for instance, it might be that a market's being manipulated. And if that goes on chain, you can actually dispute that and say like, hey, this bot, it read the price data from the data source, but this is a manipulated market. It's not the true price. And that makes it really interesting for those types of use cases. So what goes into it, you have some kind of contract, some protocol that's requesting data. They've preset a bunch of parameters like here's what the minimum bond is going to be, here's what the challenge window is going to be, maybe here's a reward for posting the data. You have some kind of process for resolving the disputes. So disputes are really rare because of the bonding mechanism. But if it does come up, it goes to a vote of all the UMA token holders, and it's kind of a Schelling point game where you commit a secret vote on chain of what you think the truth is. You can't see what other people are voting, so you can't just copy answers. The most likely Schelling point is going to be the truth. And you get rewarded only if you're actually going with that majority. And you need to have some kind of methodology of saying what the truth is. Like, what is this question? And it needs to be really explicit, because otherwise people aren't going to even come up and make a proposal. They're not going to risk a bond on like a wishy-washy, ambiguous question, because they might lose it. And you need to have some economic guarantees that bound the cost of manipulating the system. How much would it cost you to try to mount an attack on this oracle system? And there's a lot of different ways to do that. I won't go into a ton of detail on that in this talk, because I want to get into OSNAP, but come by the UMA booth this weekend if you're curious about that. So it can work for all kinds of questions. Polymarket uses us, so you can do natural language prediction market stuff. You can do insurance protocols. You can do on-chain derivatives. You can do like different fundraising mechanisms. You can verify a whole bundle of cross-chain data, which is what Across does. Across is our sister protocol that's built on top of UMA that's done about $2 billion of bridging volume between different roll-up chains. And it uses UMA to verify that all the relayers are getting refunded correctly on those chains. Yeah, kind of going through that. All these things are like live in production, pretty easy to spin up. We have tutorials for all of these, so if you're interested in any of these topics, you can do it. But we'll focus on optimistic governance, how OSNAP works, and how it could be modified for cool hackathon projects too. So this is that flow I was talking about. Like you talk on the forums and like everybody's involved there and it's free to do. You have a snapshot vote, that's also free, so everybody that has a token or like has some voting permissions can participate. But then there's just a jump off point where like, okay, the DAO is actually run by this multisig and it's just like 3 of 5 people decide what actually happens. So that's a huge, huge problem. I mean, it's like, it removes that decentralization, and we've seen a lot of adoption from DeFi protocols because they're the most concerned about that centralization risk. There's like a lot of negatives associated with that. So with OSNAP, you can still vote on Snapshot, so you don't have to pay for gas on chain. You don't have to do like these delegated voting schemes. You can vote gas free. Transactions that are approved, they're validated by the Oracle, and then they're automatically executed. Anyone can dispute the transaction, and it's usually like a long challenge window. It's like a 1 to 3 day challenge window in this case, because DAOs aren't in that much of a hurry. Depending on your Oracle integration, you might want to have just a couple of hours if you need something done fast, like Polymarket. It's a 2-hour challenge window. With OSNAP, it's 1 to 3 days. And then the truth is economically incentivized, and you can set it up in under a minute, actually. So if you have this pattern where you have a safe multi-sig on chain, and you have a snapshot space. I did a speed run. You can actually do it in under a minute of adding OSNAP, because it's this really lightweight module you attach to a safe, and then a plugin that you add to your snapshot space, and that's it. That's the entire thing, and now your DAO is like decentralized. The multi-sig does not have to get involved in actually executing things. So we're getting a lot of adoption. I had to add a bunch of logos to this one today. So we've got CowSwap, Connex, Premia, L2DAO, Across, Shapeshift, Barnbridge, Lossless, PlusDAO. And you can kind of see that theme that I was talking about with DeFi protocols. There's a ton of regulatory and legal scrutiny. Like, people do not want to be multi-sig signers on a DeFi protocol. So it's securing, I think, oh, I said over 100 million. It's close to 100 million. I was exaggerating on that slide a little bit, but it's growing really rapidly. And we think it's found a really good fit. And this is just kind of the flow. You deploy the module, just a really small contract. It's like 100 lines, just a lot of comments mainly. You attach it to your safe. You're setting the parameters. We've got some defaults. The defaults are just like a 2WETH bond that you have to post as a proposal bond. But we'll get into how that's kind of automated and some services we run around that. You create a snapshot proposal like normal, but you can attach transactions to it. So when you have our OSNAP plugin there, you can actually define specifically what transactions you're approving. You're not counting on the multi-sig signers to read what you voted through and then like figure out what the transactions are and execute them. You see what they are and you build them. And then if it passes, either the transactions are going to be proposed on chain, and after a day or two or three, they'll be executed, or they'll be proposed and there's a dispute because maybe it didn't pass on snapshot and it's actually somebody trying to like do something they're not allowed to do, in which case it gets disputed and it's basically like thrown away. You don't have to rely on the UMA token holders here exactly, because UMA token holders cannot execute transactions against your DAO. Any disputed proposal is tossed. And it's using tools that are really familiar, just using a Gnosis safe, a cool little logo for the Zodiac framework for adding stuff to a Gnosis safe. There's all kinds of other cool Zodiac things that you should check out for the hackathon. Snapshot and UMA. And this is kind of like the walkthrough. You know, it's pretty straightforward. If you go to uma.xyz/osnap, it'll have links to more docs for this, so I won't walk through all these steps. Links to like the videos showing how to set this up. But one thing I would add is once you deploy, if you're doing custom rules, and I'll get into that, just modify the rules that are in your contract. So instead of the rules saying like, here are the rules around snapshot, you could say like, here are the rules for how I want this safe to behave. Maybe I'm putting my personal funds into this safe. I want an automated investing strategy, or I want some safeguards. Like I got a Bored Ape in there. I would never transfer it. If it's being transferred, it's being stolen. So like block that transaction. You can add any custom natural language written rules that you want for your hackathon projects. And definitely contact us if you're like doing a deployment for an actual DAO that you're involved in too, or something else. Kind of just showing what it looks like. Circling the OSNAP module in Zodiac. This is in like the safe interface. You like add the Zodiac app to your safe and then click the button for the OSNAP module. It'll deploy with the defaults and you're pretty much ready to go there. Yeah, here are like some defaults. You enter your snapshot space URL. This rules parameter, like this natural language written thing, that's what's going to be enforceable with the Oracle. And it'll just plug in the values that you put in there. And there's a bunch of boilerplate too, like, you know, what if your snapshot admin went rogue and they set like a quorum of 1 and a voting period of 1 minute and they passed it? Like, it's not going to be valid because it's not meeting the minimum voting period and quorum that you set here. Like, the Oracle will check that. It'll get disputed. If Snapshot itself became evil and they're like censoring your votes, and like this is a notorious thing that Snapshot is now doing, that also can't just transfer tokens from your DAO or something. All of those extra rules are there for that. And this is actually automated now. So we have like a V2. It is basically a bot that Risk Labs runs, because we know that it's a hassle to post a 2WETH bond to make a proposal, and like a hassle to go back and execute it after the proposal challenge window is over. So we just have a bot that we run that does this on your behalf. It watches your snapshot space. We know all of the OSNAP deployments that are out there, so we can monitor them. And we'll make the proposal, and after a couple of days, we'll execute the proposal for you too. And we actually cover the gas. Like, unless your DAO is doing a ton of contract deployments or something and it's starting to get expensive, we're happy to cover the gas for whatever token transfers. We just want to make this as easy as possible to use. And the bot doesn't have any special permissions. Like if the bot is offline, you can click the buttons yourself in the snapshot interface to do it. And anybody can dispute it too. If the bot got something wrong, go in and dispute it and take Risk Labs money. Enjoy. Yeah, and these are just like extras. It's all audited. You can set it up on a ton of different chains. It's really beginner friendly. You don't need to write any code for it. You don't have to go to the command line for any of this. Like if you're just setting up a DAO as just a person who's interested in DAOs, you can deploy your snapshot space and your safe and your OSNAP module and everything else and understand how the module works without writing any code. You can deploy a token too. I mean, you can do like the whole Open Zeppelin governor module and like deploy a token, do the whole like end-to-end process without ever writing any code, which is kind of cool. And we got some new stuff coming out soon too. We're going to have a native safe app just for OSNAP and a snapshot plugin that is going to improve the transaction builder and make the whole experience nicer. And then this is kind of more of the hackathon thing. So you can think of OSNAP as a specific product, a specific use case for this optimistic governor contract. What makes it OSNAP are the wraparound things like the snapshot integration and this set of rules specific to snapshot. But you could write all kinds of rules that do all kinds of things. Instead of writing a smart contract where it's enforcing in code all of the things that this safe or this contract can do, you can write something that just is human readable and makes sense and say, this is the way this safe behaves, here's the incentives around it. Something simple like if you said, I want to sell ETH if it like goes above $2,000 and like stays there for at least an hour, and if you go and sell this ETH for me, you can take like $2 worth of ETH out of my safe. Write that out literally just how I said it. That seems reasonable enough. That's interpretable by the Oracle. Attach that as your new set of rules for your OSNAP module. You've now created a different product. It's like not a snapshot thing anymore. You've created this product around like automated ETH investing. You could add like any kind of set of rules you want, and that's kind of where the creativity comes in because, again, you did this like 1 minute kind of deploy thing. You've got the safe. You just got to figure out what the rules are and like why would this be a product people would actually want to use. I think that makes it really cool and open-ended, and it's nice for like a weekend hackathon because it's quick to deploy. And if you come up with the idea and you can write down the idea clearly, you kind of have half of the product already. You save yourself writing a lot of code. Like the sentences are being enforced rather than coming up with code that does everything. And you can maybe focus on the front end stuff and like other aspects of it. So it's really our most advanced form of generalized contracting. You can like write these contractual agreements in human readable language, and you can enforce them on chain with the Oracle checking that everything is being done correctly. So you can get maximum flexibility with minimal trust. And here's like a link. DM me on Twitter or come by the booth. We'll be there pretty much all weekend. And there's a lot of other stuff too. I mean, like we've got prediction market tutorials, insurance tutorials, just like general data assertions. You can build derivatives with us. You can like do a lot of cool stuff with our cross-chain bridge. So it's not just about OSNAP. It's just like a newer thing that we're very excited about and think raises a lot of possibilities for new products you can build at the hackathon. But that is all for me. Are there any questions on it? I don't know how we are on time. I feel like I was blasting through that. Oh no, we've got like only 5 minutes? Okay. Yes?
As I understand it, it's like an on-chain validation layer for snapshot governance, right? So as I understand, just my assumption, you get the snapshot data somehow written on-chain, so there must be Oracle that watches snapshot. Is that right?
Yeah, so basically the way the optimistic Oracle works is anybody can make any kind of assertion on chain. So in this case, the bot is basically watching snapshot. It sees what transactions were approved on snapshot, and the specific assertion is this bundle of transactions was approved by this snapshot vote according to these rules for this OSNAP space. And then after the challenge window of a couple of days, you can execute those transactions. And like what's happening technically in the contract, obviously you're not storing all that transaction data, that's really expensive. You emit it as events so everybody can see it, and so you can populate front ends, and like disputer network people can watch it, and like other bots can pick it up. But you store a hash of the transactions, and you make sure that like that hash matches like the actual transactions when you come back in to execute.
So does the bot kind of put any data on chain from the snapshot? Like let's say I put a vote and I write something obnoxious in there, like can I get that data on chain with your gas because it watches my snapshot?
Well, I guess so. I mean, if you had a transaction that is writing the data somewhere else, so like what the bot is going to do is it's going to execute your bundle of transactions. So if your bundle of transactions includes writing something obnoxious to some contract somewhere, then you could do that. It's not going to automatically pull anything from your written snapshot proposal. It only cares about the transactions. And then it'll also like emit in the events a link to like IPFS or like the IPFS CID for the specific snapshot proposal, so you know like which one you're talking about, and you can go and check that it passed and all the transactions line up correctly. No problem. Yep.
There's OSNAP, the contractual text, and it's supported UTF-16 and more characters than just, like if you wanted to use various Unicode characters, it's supported.
I think so. I mean, it's just like basically a string. So anything that you can like put in like a string in Solidity, you can put in there. You know, it just needs to be interpretable to whoever is going to be evaluating it. So whatever your rules are, they have to have, you have to be able to publicly verify whatever the outcome is, and it has to be deterministic. And you have to be able to look at it historically too, where you were like, this thing happened. If there's a dispute, the voters might have to look like a day in the past, like was it true at the second that this person made the proposal? But those are the main considerations. And the question was whether you could have like certain like characters, like special characters in your rules. Yeah.
Who can run the bots that actually do all of this? Because it does remind me of a counter extraction. And the same issue there where like the bots can get trained because of like they can make a proposal so that it reverts once it's like if the bot even does any off-chain validation, it still can revert after that, right? Like once it tries to perform them on chain. So is that like who can run those bots and how difficult is that? What kind of validation do you have to do?
Anybody can run the bots, and you also don't have to use a bot for it either. Like if nobody's running bots watching a snapshot space, there's like buttons that'll pop up in the snapshot space when it's time to propose and execute. I think that the bot logic does check for reverts so that it's not going to like waste a bunch of gas, but it's fully permissionless. So anyone can run a bot. There's docs up to do it. It's open source code, and anybody can also dispute anything too. So the bots have no special permissions associated with them. Not really. Like our incentive at UMA is we want people to use OSNAP, so we just made it easier. Like before the bots, it was just buttons and snapshot, which is still pretty easy, but you know, just fully automating it seems nice, and we're happy to pay like basic gas fees for, like DAOs aren't doing a ton of stuff. Like you're moving some tokens from time to time. It's not wildly expensive. Cool. I think that's it for me. Thanks everybody. All good? Cool. Hey guys, I am Greg with ENS, and today we're going to be talking about all things ENS. So before I get started, raise your hand if you have an ENS name. Okay, awesome, a bunch. That's good. Sweet, so I'm going to be going through a few things. First of all, what is ENS, why it's important. Some of you guys, it sounds like, will know this stuff already. Then we'll get into more technical details, some of which you might know, some might not. How do people use it today, our bounties, and all of that stuff. So first of all, what is ENS? ENS is a decentralized, permissionless naming protocol that lives on Ethereum and is built to scale to the entire internet. Right? DNS solved the problem of IP addresses to human-readable domain names, and we all use it today. ENS solves a similar problem, but was even worse for crypto because Ethereum addresses are impossible to remember, and so ENS abstracts those IP addresses away and makes it into human-readable names. Cool. And the idea is anywhere you read or write an address today, you should be able to use an ENS name instead. So you'll see over here, I have luke.eth sending something to gregscroll.eth, and then I have gregscroll.eth sending something to a long random address which has to get truncated because nobody's going to remember it. And if you ask me, the name to name is just a more enjoyable experience for everybody on chain. And here's another example of using ENS out in the wild. If I'm sending Ether to somebody in a MetaMask or any asset in basically any wallet, I'd rather send something to a name that I know rather than a long hex address that I'm not going to remember. And so this really shows that ENS started as a Web3 username, right? Instead of an address, use a username. But over time, it's becoming more of a Web3 profile. And in order to do that, we have two different types of resolution. So forward resolution is what you just saw in the MetaMask example. I go in, I type a name, and that resolves to an address. But the thing here is I can have multiple names that resolve to the same address. And so I can register a .eth name today that resolves to some of your addresses out in the audience. But really what makes it a portable profile is the opposite, reverse resolution, or having a primary name. And what that means is the controller of the address basically sets a name that they want to be their global Web3 profile. And so in this case, my address OX179 will reverse resolve to gregscroll.eth because gregscroll.eth is my primary name. So what this means is when I log into different applications across Web3, I'm kind of greeted with this universal Web3 profile, right? I see gregscroll.eth, I see my avatar, and it's just like follows me around. And this is another view of that profile. I have a name, I have an avatar, like you saw before, and I also have all of these other text records, as we call it. So text records allow you to store any arbitrary data on an ENS name. And we'll get into exactly where that works later on, but it's just leaning into the idea that this is really a universal global Web3 profile. And all these websites on the bottom are just third-party websites that people have created that kind of identify me as my ENS name. That is my, again, portable Web3 profile. Cool, so now we know what ENS is, but why is it important? So it's cool, it's fun, it's portable, extensible, multi-chain, public good, it's decentralized, and most importantly, it improves the crypto user experience, right? And so if we look at Ethereum over here, the Ethereum logo, ENS, the entire ENS branding and logo is just a nice friendly wrapper on top of the Ethereum logo because it's a nice friendly wrapper around the user experience of Web3. So what are the different types of ENS names? And I think this is where we're going to get into some misconceptions. So a lot of people assume that .eth is ENS's only type of name, right? But that's actually not true. And so you can use almost any DNS name as an ENS name as well. So this means .com, .xyz, .io, or anything else. And then the MetaMask example that I showed before would work with any DNS name. So for example, you can go to MetaMask and try and send something to ensferry.xyz, which is a DNS name, and it will resolve to an Ethereum address just like any on-chain .eth name. So there are a few differences between these two things. First of all, .eth is really the only blockchain native TLD in the ENS ecosystem. So it lives on mainnet Ethereum. It is fully decentralized. The only way something changes about .eth is through an ENS DAO proposal and successful vote. So there's no single entity that can change any of the ENS.eth core contracts.
And .eth names have a small annual fee each year to prevent name squatting and basically promote a healthy ecosystem. So this means if names go unused, then eventually they will be recycled and somebody else can pick them up. So this is .eth, kind of the top dog in ENS in terms of decentralization. Next, we have DNS. And ENS as a protocol respects existing internet infrastructure. And it's like the realization that DNS works pretty well. You know, all of us use it all across the web every day. And so we want to allow DNS name owners to use that in the ENS world as well. So using DNS names in ENS has no protocol fee, although in the past there has been a pretty substantial gas fee to use this. And the reason is because you're submitting a proof on-chain saying that you actually own the DNS name. Soon, you'll be able to use DNS names in ENS completely for free, including gas. And this will be powered by something really cool, which I will show you in a second. And it's powered by ENS names that are off mainnet, right? And so this is all powered by a cool standard called CCIP read. And before I dive into that, with these off-chain names, there is no ENS protocol fee. There's no gas fee. There is ultimate flexibility because the developer can really do whatever they want and read from any data source. And like I said, CCIP read is a Ethereum standard, not just an ENS standard, to securely retrieve off-chain data from smart contracts, and it gets verified on the front-end level. And again, we'll dive into exactly where that falls into the ENS kind of flow in a few minutes. And just to point out that these off-chain names powered by CCIP read are already used in production today by some pretty large teams like Coinbase, Lens, Eco, and so on. And so here is a simple example of what that might look like in the wild. And I'll go back to the QR code after if you guys want to try it out. But basically, let me make this bigger. Cool. So this is what it could look like to register a free off-chain ENS name. I'm just going to say testing like that. And so I'm going to have testing.offchaindemo.eth. And I'm going to set my description, which is basically an ENS text record. And so this would normally be on-chain and cost gas to be hello. I'm going to press register here and just sign a message. So nothing on-chain at all. I'm not paying anything whatsoever. And boom, I just created an ENS name. And so if I press view in ENS Manager, you'll see that testing with a bunch of G's .offchaindemo.eth just like works, right? And I can copy this name and go into MetaMask. And if I wanted to send Ether to this name, then it works right away. And that was free for me as a developer, free for the user, and overall a great user experience. So let me go back. I'll point out here that the docs on how this works, which I'll mention in a minute, and the exact code is linked in the footer. And so I'll leave this up just for a second if that's interesting to anybody and you might want to do something similar as part of your hackathon project this weekend. Cool. So, oops. With all that, how does ENS work and where does this CCIP read off-chain stuff fall into the mix? So ENS at its core is just a registry on mainnet Ethereum. And in that registry stores a name alongside a resolver. A resolver is also a smart contract, which basically stores everything, all the data for a name. So these text records that I've been talking about, the address that it points to, and so on, is all historically stored in a resolver. So you'll see that the same name can have multiple, but the same resolver can be used for multiple names. So I'm Greg.eth and we have Rekmu.eth in the audience over here. We both use the same resolver, OX4976 and so on. But also you can have custom resolvers. And anybody can develop their own custom resolver, which has whatever custom logic they want. And so you'll see offchaindemo.eth has a different resolver than the others, and that's what allows it to do cool things like have that off-chain registration. So if we look at the default on-chain resolver, again, OX4976 and so on, basically this stores all the data for a name in just internal storage. So if I wanted to set the Ethereum address of Greg.eth, I have to make an on-chain transaction to this contract saying update my ETH address from OX179A to whatever else. And same with the text record and so on. It's important to note that address and text are basically like objects, and so you can add, so text records, for example, support any arbitrary key value pair, and address records can be set for multiple chains. And so that's another misconception that ENS is only for mainnet Ethereum. It's really for any layer 2 or even other networks. So you'll see right here, rickmoo.eth has set an ETH address and a Bitcoin address. And so if you were to go to a wallet that supports this standard and you type in rickmoo.eth, then it would allow you to send Bitcoin to rickmoo. And so that's pretty cool and something I think most people often miss. But now, what is different about the off-chain demo.eth resolver? And the answer is basically everything. So instead of looking at internal storage for addresses and text records and so on, it reverts with this off-chain lookup. And this revert is exactly what CCIP read is. It's a standard that defines a custom error in Solidity, and it tells the client to do something different. So that something different is basically look off-chain at a data source of your choosing. This can be a database, like how Coinbase does in Coinbase Wallet. If you're to sign up as a new user, you can claim a free cb.id subname, and that uses exactly this. And you could also use it to look at a layer 2 and stuff like that, which I will get to in a second. CCIP read works really well in conjunction with ENS IP 10. ENS IP is just an ENS improvement proposal, and 10 is the number for wildcard resolution. And so what that means is if a client attempts to resolve a name that does not exist on chain, then it will go up to the parent and basically ask that parent if it has a record for something below it. So the name that I created before, testing with a bunch of G's, does not exist on chain. And so the front end client would then go to offchain demo.eth, see the resolver of offchain demo.eth, and then make a request from there basically to get the data wherever else it might be stored. And so again, it is a matter of internal storage versus reverting off-chain to get the data from somewhere else, and that is powered by CCIP read and ENS IP 10. So if we just take a step further, how can ENS work with layer 2s, which is a common question that we get? And really, the answer is the same, right? This is exactly the slide that I had before, offchain demo.eth, revert with offchain lookup for each type of text record that we have. And what I want to point out is that that off-chain lookup, again, can be anywhere off of mainnet, including a layer 2. So how do these different approaches kind of change the resolution process? The first one is what you might know as ENS today, meaning everything being on-chain. A client will go to the ENS registry and find a resolver, and that resolver will have internally stored the data for the name and just return it, right? Very simple, but somewhat limiting because it's just a mainnet Ethereum contract. The next would be using CCIP read. So a client, like a front end, goes to a resolver contract. That resolver contract says, actually, I don't have the data, but if you go to this gateway, it will tell you where else to get that data. And then that gateway pulls in the data from a centralized database. So again, this is what Coinbase Wallet does because they're not treating users as people who are obsessed with decentralization and need everything to be totally permissionless. We have options for that, but not everybody is of that mind. And so it's okay to have a database for a good user experience. And then the database returns the data on chain, and that resolves the name or returns whatever data you're requesting. The next approach would be basically just replacing the database with a layer 2 contract. So same process, front end goes to a resolver on mainnet. That goes out to a gateway. The gateway then pulls the data from a layer 2 contract and returns the data, so on. The problem here is that the gateway in both the second and third example are basically fully trusted. So if the gateway wanted to just not read from the layer 2 resolver, even though they said they would, they can do so. And so again, that's okay for some use cases, but not all. And so the kind of coolest approach to this, and something that's being more actively explored recently, is adding a verification to that layer 2 state on mainnet. So again, the client would go to a layer 1 resolver. The layer 1 resolver would go to a gateway. A gateway would go to the layer 2 contract, and then once that data is returned to the client by the gateway, a contract on layer 1 verifies that that data is legit by checking basically the proof that the layer 2 deposits on layer 1 every X period of time depending on the layer 2. And so what this gets you is a trust minimized gateway that cannot return bad results because you have a contract on mainnet verifying these results each time. So in the first case, it is fully trustless, but expensive. in the middle two use cases, it is basically fully trusted but free. And then in the last use case, it is both free, or I guess you pay layer 2 gas, but it's cheap and trust minimized. So the worst that the gateway operator can do is just shut it down and stop operating, which of course isn't ideal, but they can't fully attack you by like changing any data. And yeah, so those are basically the different approaches and why you might want to do each one, and why the last option is a cool one more recently. So now we have a good understanding, hopefully, of what is ENS, how does it work, why you might care, and different kind of extensions to make it work beyond mainnet Ethereum. And so it's really just like, how do people use these names? Like I said before, it's really a portable Web3 identity. This is how I represent myself on chain, and my usernames places, my display name on Twitter is gregskrill.eth, because this is really just what I lean into, and everything that I store in this profile is kind of officially me on chain. Next would be communities. Communities have really taken a liking to ENS subdomains as a way to feel part of a community, right? So pcc.eth is a popular NFT project that only allows NFT owners to claim subdomains of pcc.eth. And so if you look on Twitter and you search pcc.eth, you'll see a bunch of users that like rep this name as their display name on Twitter. And they feel part of this community, and it's proving that they own an ENS name and part of your identity. Next would be immutable text records. So like I mentioned before, ENS names can store any arbitrary key value pair as a text record. And so Uniswap, somebody made a proposal to the Uniswap DAO to establish v3 deployments.uniswap.eth. And on this name, they set a number of text records for basically official deployments of their Uniswap contracts across different chains. And so any user of Uniswap, if even front ends get hacked or anything like that, the only way that this name can get changed is by a DAO proposal. So it's really like an immutable record, an official list of their deployments. And so it's a very different use case for ENS, but something that certainly makes sense. It's just a generalized data store that can be used in any creative ways that you come up with. Next would be naming contracts. So a lot of this has been about identity and paying people personally or representing a single person on chain. But also, like, we deserve to have good user experiences around contracts as well. And so you'll see here under ens.eth, we actually use this ourselves to name a bunch of the ENS protocol related smart contracts. So if you were to go to Etherscan and search registry.ens.eth, it will bring you to the ENS registry smart contract that I was talking about before, which is kind of like the home base for everything ENS. And this would allow wallets to basically display that gregskrill.eth is interacting with registry.ens.eth. That is so clear, and it makes so much sense, and you don't need arbitrary labels per block explorer and so on. Again, it's just a way to improve the user experience of Ethereum and Web3 overall by way of ENS. Next would be usernames. So ENS as a profile, ENS as a username, really is just like the most obvious example, I think. And Farcaster, a decentralized social protocol, recently took this and kind of did exactly that. Instead of having their own centralized username space, they allow you to bring your own decentralized ENS name and use it as a username across the protocol. And so I can go to different Farcaster clients, and I can see that a username is an ENS name across the board. And it's a cool example of like connecting protocols across Web3 for something that actually has tangible use. And people have seemed to really enjoy this. So usernames are definitely one of the more obvious and just like cool examples of ENS, I think. And then last, but certainly not least, Web3 messaging. So our friends at XMTP are also here this weekend, and they utilize ENS for a number of things. This is what XMTP looks like inside of Coinbase Wallet. And you can see I am messaging other addresses like slobo.eth, a friend. And you can imagine how if I was messaging OX1234, so on, it would just look ugly. ENS names make the user experience better by having human-readable names for all types of crypto addresses. So now we have a good understanding of hopefully many things ENS, and let's give you some resources to move forward. So first, we have a front-end quick start guide. This will allow you to very easily get started with an ENS app on the front-end side in just a few minutes. It is a full doc running you through things, and also there's a GitHub repo that you could just clone as a template and get off to the races. I'll point out that there's a QR code on this slide and the next one if you want to scan that. But you'll see here that it's really just a few lines of code with any popular Web3 library, and you are off to the races. Next is the Thorin design system. So this is actually a little bit detached from ENS protocol, but just a cool developer tool that we've been working on. And it makes it easier to build cool looking ENS applications very quickly, or just cool looking applications quickly. It's a React component library that I've had a lot of fun using, and I think you might too. So really quick, the last thing I want to do is highlight the prizes. We have a range of them. $2,500 to the best overall use of ENS, $2,000 to the best use of ENS subnames. That could be on-chain, off-chain, layer 2, like I described. The option is up to you. $2,000 to the best implementation of ENS with account abstraction. So think combining certain ENS transactions to the initial contract deployment. And $1,000 to the best use of Thorin. And then $500 to 5 honorable mentions. So open to your creativity. It could be subnames, it could be account abstraction, or anything else. It's up to you. So thank you. I hope this was helpful. We have a booth. If you have any questions, we'll be there to help. Or message us in Discord, and we'll be able to help you out.
Okay, we are ready to get started. I'm going to be going kind of quickly because we only have 20 minutes. So hopefully you'll still get a lot out of this, and I'm not going so fast as to kind of not explain some of the core concepts here. But I'm going to be talking about building full stack social applications today, and we're going to be combining a presentation at the beginning with an actual coding demo at the end. And the team that I work with is Aave and Lens Protocol, and Lens Protocol specifically is what I'm going to be talking about today. I'm Nader. I've been a developer for about 11 years, worked in the traditional tech world in cloud and mobile, and then have now been in the blockchain world for a little over 2 years. If you want to get a reference to the resources we're covering here today, I'll give you a couple of minutes if you want to scan this QR code. If you want a Lens handle, by the way, also come by the booth today. We can get you set up with one. If you want some swag, come talk to us. We have a lot of swag there. We're trying to mainly get that swag to people that are building on Lens or Go. But if you come like maybe tomorrow and we still have some swag left and you're not yet building on Lens or Go, and you can still pick some up. But if you are building on Lens or Go, definitely come speak to us. Okay, so I'm going to first introduce Lens. So what is Lens? Speaking to developers here, I'm going to give a different description than what Lens is to like a user. For a user, you can kind of think of it as a like social layer for Web3, or just really a composable social graph that allows you to take your identity and your followers across multiple applications and multiple experiences. But for developers, I could say it's more of like a protocol and a suite of tools and APIs for easily building social apps or integrating social features into existing apps. The way I like to kind of describe this that might resonate with traditional software engineers, it's kind of like a managed service offers features like Auth0 or Okta might offer authentication for you for your application. You don't have to build all that from scratch. You just tie into something like Clerk or Auth0 and you're good to go. You have things like S3 for file storage. You have even, I don't know, there's all sorts of these managed services out there like Twilio for messaging. You can think of Lens Protocol as a managed service for building social applications or social features into existing apps. So you don't have to build or manage this backend infrastructure. It's all there for you. You just build out the front end, either a web or a mobile app. And social is really interesting because it's kind of the biggest use case that there is in software today, I think. 4.9 billion people are familiar with social. It's not like a lot of other blockchain technologies where there's a lot of onboarding and friction for people to have to understand like why they would use this in the first place. It's just something that people are already knowing and understanding as well. And I think it's also interesting to see the two biggest social founders in the history of the world, Mark Zuckerberg and Jack Dorsey, also moving into decentralized social. Jack with Blue Sky, who then moved on with Nostr. And now you see Adam Mosseri, who's the head of both Instagram and Threads, giving a talk at TED last year talking about building decentralized social applications. And then one of his first posts on Threads is talking about how Threads is moving into a decentralized network. And some of the language he's using here is Web3 language, portable social graphs, censorship resistance are some of the themes here in one of his first posts. And I think it's really interesting and validating for anyone here that's been building in Web3 to kind of see that these ideas in practice actually do make a lot of sense. And I think when applied to social, it makes especially a lot of sense. And hopefully you can see why by the end of this talk. So a social application doesn't necessarily mean an Instagram or a TikTok. It just means that you're implementing a feature that has some type of social functionality into your app. As developers, what are some applications that we might not think of as social that are social? Well, GitHub is a very good example of this. I don't use GitHub only for storing code. I use GitHub for discovery of new APIs and new applications and new software that the people I follow are building, because I can follow a developer on GitHub, and now I have a feed of some of the most interesting things that are happening in the software space because the algorithm is giving me that information based on who I follow. So there's all types of ways that you can integrate social features into apps that don't necessarily have to be a social app in the front and forward main selling point. And Lens basically allows you to do that. Lens is at the core a set of smart contracts deployed to Polygon, but what really makes Lens powerful, I think, as a developer, is more about how easy it is to build with. We have a lot of different things that you can use that kind of abstract away the traditional complexity of building on a blockchain. We have a GraphQL API that allows you to query it like you would a database. So you can say, give me profiles that have been created, like, for instance, at a certain point in time, or that might have you might be able to search publications and sort and filter and all these things that you can do with the database. Our API allows you to do that. We also have a lot of interesting SDKs and developer tooling and things like that that allow you to build more quickly than you would that by calling like just raw API requests that I'm going to show in just a moment as well. For UX, for the actual user-facing things that we've built into the protocol that make it kind of more of a desirable place to build than just directly on chain, is our gasless transactions and our dispatcher. Gasless transactions basically mean that the user doesn't have to pay for anything. So when a traditional like blockchain application is launched and you want to get a user to use that, the onboarding flow is actually very, very, very bad. You have to explain to that person that they need to download this wallet and they need to create a private key. They need to go to the bank and they need to open an account, and then they need to connect that account to an exchange like Coinbase. Then they need to buy the right token. Then they need to send that right token to the wallet and be on the right network and then exchange for whatever token it is that works on, right? That's a shitload of friction, right? Users are like very hard to come by already, and when you put all this additional friction, that's kind of a no-brainer while most blockchain applications don't have any users. If you think about building in the traditional Web 2 world, people literally make onboarding seamless as clicking on a button to sign in with Google, and they still can't get users. So I think that making this onboarding process as smooth as possible and not requiring all this is super important. So with Lens applications, the user doesn't need tokens, they just need a wallet, and then they can start using the app for free. And the reason that it's free is because we've upgraded and improved our infrastructure that I'm going to talk about in just a moment to make transactions super, super cheap on an order of magnitude of a traditional database, a couple of orders of magnitude, which makes it very, very inexpensive. I'll show you some numbers in just a moment. And then also our dispatcher at the API level allows you to just sign a single transaction saying, I can post using this account without having to sign every other transaction going forward. So the end UX ends up being more of something like Twitter, and I will try to kind of show an app in just a moment. And then the developer experience is something that I'm going to show in just a moment as well. So one of the things that has been a challenge for building this type of application in Web3 is the scalability. If you look at a database like DynamoDB, I used to work at AWS for a little over 3 years. We had applications that literally would be able to handle, that did handle around 100 million operations per second for a single application. We have blockchains that are supposedly scalable that can't even hit a few thousand transactions per second, and this is a shared environment. Like, not only that blockchain can only handle a few thousand TPS, but that is being distributed between every application ever launched to that blockchain and every single user on every single application that's launched to that blockchain. Clearly not a good use case for social, and I think that we're starting to see a lot of improvement in this space with app chains and things like that I think are going to be great. But even with that, today you cannot build using a traditional, what I would call a financial blockchain that has the limitations around fixing the double spin problem, which turns out in social doesn't even matter, because who cares if me and my friend post at the exact same time? The only thing that we care about is that that content is going to be there, it's going to be immutable, and it's going to be available for people to kind of use and be able to read publicly. So removing the constraint of the double spin problem allows you to use a protocol like Arweave, and Arweave is a protocol that's built specifically for data storage, and it's not built for financial use cases. It's more just built to store files and stuff. So our new infrastructure uses Arweave, and it's called Momoka, and at the last time that I checked, we had hit around 800,000 800,000 transactions for a total cost of $261. I've paid $261 for a single ETH transaction during the bull market. So this is 786,000 times more scalable than that one transaction that I did. Obviously, that's not the typical cost. The typical cost for a transaction on like a new L2 is probably closer to like a few cents. But still, we are orders of magnitude cheaper than that. And therefore, it makes it easy for us to be able to subsidize all the transactions on the network at this cost. Now, in terms of developer experience, we have the GraphQL API that I talked about a moment ago, but we also have SDKs. So we have the Lens SDK, which is both a React Hooks SDK and an agnostic JavaScript SDK. The React Hooks SDK just allows you to call APIs with 2 lines of code. The Lens client is a more agnostic JavaScript SDK that also allows you to kind of make requests with just a few lines of code. It sits above the Lens API. So instead of having to understand and format GraphQL, you can just say, give me publications or give me a profile with this ID, 2 lines of code, you have that data back and ready to roll. Whoops, this is what the API looks like. So you just import the hook and then you render data, loading, and error, which kind of gets returned from you there. And you also can pass in arguments for different props, things like sorting and filtering and stuff like that. We have a UI kit for React Native. You can get started with 2 lines of code as well. You can render a feed, you can render a publication, you can render a profile, all sorts of stuff. And then we have a widgets library. This is kind of an idea of what those widgets look like when you render those out. You have a way to share profiles. We have a way to share content. You have a way to sign in with Lens using it more of like as an integration, which is what most of the time these widgets are used for. But it's also just a really simple way to kind of get started with Lens using just a couple of lines of code. And then finally, something that a lot of people have been building some of the most interesting stuff with is our BigQuery data set. So with our BigQuery data set, I think we have like 65 or 70 tables that allow you to literally query every piece of data in the history of Lens in a fairly short amount of time. And with this, people are building things like analytics dashboards and recommendation algorithms. And then we integrate really, really closely with XMTP. There's a Lens namespace that allows you to kind of integrate with every other Lens app. So if I send a DM on Orb and then someone else opens it on Butterfly and then you build a new app, you'll have all of those DM conversations integrated into your app without having to do much work. A couple of the core features of Lens that I think are super important to highlight that aren't really specific to Lens, it's more of like a Web3 thing, but I will just underscore them because they really shine with Lens. One of them is extensibility. So with Lens, and especially with Lens V2, which was just launched to testnet a couple of days ago, you can build your own custom functionality with custom modules and what we call open actions. With these new features, or with that new feature, open actions, and with custom modules, you can basically, it would be like if you could submit a pull request to Twitter and add a feature that you wanted, you can do that with Lens. So if you see something that you want that isn't already there, you can kind of integrate this. And this also opens the doors to a lot of cross-chain stuff. So we're already starting to partner with some other protocols that are outside of the Polygon network that allow you to interact and integrate with their applications and vice versa. And then there's this idea of composability. Composability is a big thing with smart contracts because anyone can just build on top of each other's contracts and you have all of this DeFi stuff that happen and there's all types of stuff you can do that. But beyond that, I think it's important to underscore that the protocol itself is almost more of a managed infrastructure service like you would see with traditional cloud providers. Because not only do all of these things exist, they continue to be maintained and improved over time. And you as a developer only have to focus on the front end. So you can be a front end developer building web or mobile apps and not have to build and manage DevOps, infrastructure, database, all of this other stuff. And you also inherit the existing Lens user base, so you don't have to kind of bootstrap and cold start as bad as you would from a traditional application. You still have a little bit of a cold start problem because you have to get awareness of your app, but once people know about it, it's not like they have to sign up for a new profile. If they already have a Lens profile, they already have their followers on your application as well. And one of the things that we're doing now that Lens V2 has been rolled out, essentially, is we're opening up Lens protocol to be completely open for, I would say, more of a permissionless access for new users. So as a closed beta, it's been hard for people to get handles. They have to go through this process. But very soon, we're going to have a way for developers to be able to onboard users directly through their applications without any involvement from the protocol at all. And composability for developers was spoken for there. For users, it's interesting because for me as a user, I have this portable social graph, and I can focus on building my audience on one of these applications. But if I see a new application that launches tomorrow that I like a lot, I now have all of my followers there, and I can experiment and try things out there without having to kind of worry about bootstrapping from scratch. So LensTube, Orb launches, and then I see this new app that is called Butterfly. Okay, this is pretty cool. Every time I sign into a new app, all of my followers are there, and this is a really fun experience from the user perspective, and I don't think a lot of creators kind of like that. For the tech stack as a front-end developer, because you are not having to build the back end, this is kind of the tech stack you might work with. GraphQL and the Lens API, one of those SDKs that I just showed you. You still need to manage your metadata for a post. So when you publish some content to Lens, you can choose where that needs to be stored. So you can either store on IPFS or Arweave. We recommend Bundler with Arweave. You can also integrate video streaming features with LivePeer. We see a lot of people doing that. And you'll still be using some of the same SDKs that you've used in the past. Things like Rainbow Kit, Wallet Connect, Ethers, WAGMI, and on the front end, you can use any of the libraries that you've used in the past, like Next.js, React Native, whatever. Okay, so tried to go through that kind of quickly so we could get to an actual demo. What I want to do is just show you how to build a social app in, I don't know, 5 minutes, I guess. So what we're going to start with is the Lens docs. So if you want to get started, we have Developer Quick Start right here. This is a great place to get started building out what we're about to build now. And this is actually the guide that I'm going to be following. What I have built out so far for this demonstration, for this demo, is just a blank Next.js application. Literally nothing there. We're starting from scratch. And what I would like to duplicate is an experience similar to what we might see on Lenster, which is a Lens client, or something like Twitter. And most social applications have two types of views. You have a feed of publications and you have a feed of people, right? Like if you think about almost every application that you've ever used, you have those two main components. You click on a profile, you see a feed of publications from that user. You click some type of recommendation algorithm, you see a feed of publications from random users. You click on a user's profile, and you want to see their followers, and you have now this feed of followers. So we're talking about feeds of publications and feeds of followers. We want to start our application from either one of those points. So for this demo, we're going to start with the feed of users. There's a couple of ways I can do that. Here in my code base, the first thing I'm going to do is just show you the widgets where I can maybe import a feed of publications from the widgets for React. And I'm going to delete all this code. And I'm going to drop in this like pre-made UI component, which this isn't the main thing. We're going to actually use the regular SDK, but this is just a fun demo because I can just pass in a handle for like Christina, who is here. And I can just save that. And I should be able to go here to my app and refresh. Oh, I need to use client for the new Next.js because it's like really, really awesome like that. They just assume everyone's building server-side apps now. Anyway, so now we see a feed of Christina's publications. And we got this done in just one line of code. This is very extensible as well, so I can actually pass in a lot of different props to most of these components to do things like, let's say I want to theme it. And I want to set the theme to the dark theme. We now have a dark theme. There's about 7 or 8 different, I would say, types of UI components that we can build with that widgets library. But what we actually want to have is more control. We just want the data itself, and then we can build out the styling ourselves. So instead of using the widgets library, what I'm going to instead use is the React Lens SDK. And I'm going to import Explorer profiles. And in our component here, I can just render the data from invoking the use Explorer profiles, and I can log that out. Now, if I go to inspect my element here, I see that I have an array of data that has come back with profiles that are given to us based on a very basic recommendation algorithm, because we haven't passed any arguments to that. It's just kind of given us the default. But you see that we have like a bio of a user, we have their handle, we have their profile picture, we have stats, we have all types of stuff about them. And I can even go here and I can pass in an argument that says limit like 30 or 40, whatever, because right now we're only getting back 10. And then now we see once this is refreshed, that we have 30 profiles coming back. Okay, cool. So now that we have that, what I'm going to do is go to the quick start guide, and I'm going to follow along, and I want to essentially loop over those profiles and show the profile picture, maybe their bio, and then a link to the profile details. So I'm just going to copy all of this code here, and then we're going to walk through that. So instead of returning that, we're going to rename data to profiles. And then we're going to import link from next link. And we're basically mapping over the profiles array. For each profile, we're returning a profile picture, a profile handle, and a profile bio. And if I go ahead here and I refresh, we now have a pretty ugly, but we at least have a working, functional social app that we have got started. So what I want to do next, though, is if I go to Twitter or like Lenster, I can click on a profile and view their profile details. So I want to build out that feature in my app. So what I can do now is, if you look at the link that I've created here, it links to a page called /profile. Profile doesn't exist, so what we need to do is go here to create a new folder called profile. And then in the profile, we're going to create a route called handle. And then in handle, we can create a file called page.tsx. And with page, excuse me, with this page, I'm going to get the params from the route, which are passed in as an argument. And we can now use that params that is essentially going to be /profile/ID or handle to fetch an individual profile. And instead of writing that from my own head, I'm going to go to the developer quick start and continue there. So the hooks that we're using here are going to be a little different. We have use profile, use publications, and profile. So I guess I need to call this profile component. The profile is for TypeScript typings, but these two are actual hooks that we're going to use. Because we need to first get the profile using the params handle, and then once we have that handle, we can get the publications for that user. Because what we want to render is this view here where we show their profile information, but also their publications. So the way that we're going to do that is we're going to create two components. One is going to be the profile component that I will actually just copy here. And the profile component is going to call use profile using the handle that's in the params, and it's going to return Very similar to our other page where we have like the profile picture, the handle, and the bio. And then we're going to create a new component called publications that's going to invoke the use publications hook. Publications is rendered here. If there is a profile, once that profile is available, we're going to call use publications, and this is going to return a limit we've set here of 10. And we're going to then map over the publications to render out the publication. If it has an image, we'll render the image. If it's just text, we'll render the text. All right, chances are I broke something here, but we'll try this. So now what I should be able to do is just click on a profile, and then we should be able to then view that profile and their profile information. That's the demo. What I want to do to close this out is make a quick post. Okay, cool. So I'm going to go ahead and open Orb. Oh, the camera's not working. Oh, yeah, wait, yeah, it is. There we go. Okay, so this is a Lens app called Orb. And in it, there is an ETHGlobal New York community. So what I'm going to do is take a quick picture and post it here. Actually, well, it's not connected anymore, but I'll still do that. Okay, so if you want to be in the picture, well, you don't have a choice. Cheese. Okay, so what I'm going to do then, I guess I can just post it here and show it on Lenster. So I'm posting on Orb, and we'll just also have this show up in the developer community, but also just in the public. All right, it just posted. I'm going to give it a couple seconds and then refresh. And there we are. That's the beauty of being able to kind of like have this social graph. I can post on any application that I want, and it'll probably be viewable on the application that you like the most. So to wrap it up, I want to show a couple of links. Well, when we talk about the bounties, we have $10,000 in Lens bounties. We also have $10,000 in Aave Go bounties, or not we, but the Aave Foundation does. $4,000 for best Lens app, $2,500 for most original Lens app, $2,500 for best SocialFi Lens app, and $500 times 2 for best integrations. Another view to the links. And with that, I'll wrap it up. Thank you for checking out the workshop.
get started. Is mic good? All right, we're good. All right, so hi everybody. My name is Andrew, also go by DeFi Spartan. And today we're going to be giving a presentation about building with Aave and Go. And most specifically, this presentation is going to be a lot of focus on Go because I've noticed that a lot of people have a lot of questions and a lot of interest on building on top of it, which is great. So I want to open up with this question. Why are we actually using distributed ledger? Why are we not just using these centralized products? Why are we actually focused on using these innovative networks and technologies? And really what it boils down to is the formation of agreements, specifically agreements with properties, which are very useful. Number one, open. Anyone is able to verify and make these agreements between each other. Neutral, that the agreements are made through code, not through the discretion of one single entity or actor. Self-custodial, where users are able to make agreements on their own behalf. And then finally, verifiable, where if an agreement is made and these terms are set, that anybody is able to check the terms of these agreements and make sure that they're actually executing as intended. So with these agreements in mind, let's look at what are the actual agreements that are happening with a stablecoin. So number one, the token pegged to a certain unit of value, and it has the ability to do two main things, mint and redeem. So when we actually look at these agreements, the things that you have to ask yourself when evaluating a stablecoin, how can it be minted, how can it be redeemed, and how does it maintain its pegged unit price? So we're going to look in depth at exactly how the Go stablecoin fulfills these things, and in the process see how it can be built with. So when we look at the overall stablecoin landscape, it's pretty interesting that almost 90% of the value in these stablecoins, the agreements that are happening through these stablecoins, are not actually occurring through code. They're occurring through these centralized institutions who basically have the authority over these agreements. And the entire principle of not just Go, but basically all decentralized stablecoins is to, in essence, fulfill the agreements of the stablecoin with the values of the ledgers that they're actually built on top of. So what that means is that the stablecoin itself is open, neutral, self-custodial, and verifiable. So with that enters Go. So what is Go? In short, it's a stablecoin native to the Aave protocol. And what this means is two things. Number one, it's governed by the Aave DAO, meaning that the decentralized entity Aave DAO has the authority to vote on different aspects of Go. And second is that the initial way that Go is minted and redeemed is through what's called a facilitator, and specifically this facilitator is the Aave protocol. And we'll go into detail about what exactly that statement means. So the foundation of Go is this facilitator model. If you were to go on EtherScan and look at the actual Go token contract, essentially what you would see is this model, which I'm about to show on the screen, which is that Go is composed of these different buckets. So a bucket is an address, which has the ability to mint Go up to a certain threshold. And there's really just two parameters that do this. Number one is the capacity, how much is able to be minted. And second is the level, what is the current amount that is able to be minted. So currently today, the two facilitators which have been approved by the Aave DAO are the Aave protocol facilitator, which we're going to go in detail on, and a flash mint facilitator, which sort of mimics the behavior of flash loans in the Aave protocol, if you're familiar with that. But the idea of Go is that it's a flexible facilitator model, which means that in essence, there can be any number of facilitators which have the ability to issue Go, either through code or different forms of agreements that the DAO agrees upon. So specifically, the Aave facilitator. So how exactly is Go minted or burned through this facilitator? Well, it occurs through methods which are actually pretty accessible to most people. Minting occurs directly through the borrow function, and burning the Go token occurs through the repay or liquidation functions. And to show exactly how seamless these actions are, let's actually take a look at a piece of Solidity code. So how do you actually mint Go with the Aave facilitator? So maybe some of you are familiar with kind of the core actions of the Aave protocol, where you're able to supply collateral and then borrow tokens against this collateral. And this is what the smart contract call looks like for a normal token. In this case, it's borrowing a certain amount of the token wrapped Ether. If you were to mint Go instead of borrowing wrapped Ether, it looks the exact same. To the contract developer or to the integrator, minting Go occurs seamlessly through the actual Aave protocol. And this is because the minting of Go is actually occurring, under the hood of the protocol. So this is a seamless process, but there actually are several key differences to Go, which actually provide some very interesting opportunities for builders. The first are rate mechanics. So this is kind of the model that every single other asset in the Aave protocol uses. Essentially, this is the model of the rate which borrowers are paying to borrow that asset, and it exists as a curve. So essentially, the protocol is performing this mathematical calculation every single time an action occurs, where it says, okay, what is the total amount supplied? What is the total amount borrowed? And based on that ratio and then the parameters which are determined by the DAO, that is what sets the interest rate for an asset within the Aave protocol. Go works a little bit differently because Go is not an asset which is supplied by other users and then borrowed. Go is an asset which is minted directly by the protocol, which means that it has a different rate mechanic. And specifically, the way that it works within Aave is that Go has a fixed borrow rate, and then there's a separate mechanism for a discount, essentially the regular borrow rate, and then you have a different borrow rate which is accessible based on the amount of staked Aave tokens which a wallet holds. And then specifically the way that this is actually implemented is that Aave governance has control over these three specific parameters. So through the on-chain Aave governance, which is used to govern the exact same governance process which is used for the Aave protocol, they have the ability to establish the fixed borrow rate for Go, the amount of Go that is able to be borrowed at a discount based on the amount of staked Aave, and then also the actual discount that is being given. So in this example, the APY with the max discount is 1.6%, and this is basically if you hold the maximum amount of staked Aave that Aave governance has set, this is the discount that is applied to the borrow rate. And definitely the easiest way to understand this, if you want to dive deeper into this model, is definitely just to experiment with it yourself. So on go.aave.com, this is the testnet website for Go. And on this website, there's actually a calculator on the Go reserve page where you can input amounts of staked Aave and Go, and you can model out exactly what the effective interest rate is and the amount after a certain amount of time. And this is really powerful because if you think back to the regular Aave interest rate model, essentially your borrow rate is dependent on the actions of other users. Whereas with Go, as long as the parameters are fixed by Aave governance, it provides a level of predictability, which you just really don't have in a lot of other different types of assets within the Aave protocol or in DeFi in general. And now we'll talk about something which is definitely a hot topic for Go, and that is the mechanisms of maintaining stability. And really this kind of boils down into two separate categories. So the first category is collateralization. How does the Aave DAO actually enforce that Go is collateralized? Or how does the Aave DAO decide when an address is able to mint or burn Go? And this is really based on a very simple mechanism. So I actually pasted the contract code directly here. And that is that within the Aave protocol, the price of Go is fixed to $1. And this does not mean that the market price of Go is fixed to $1. That's not the same thing. What this is saying is that in order to borrow or repay or liquidate Go, the value of the other tokens inside of your wallet must correspond to this $1. And what this means is that effectively Go has a collateral floor where no matter what the market price of Go is, the Aave protocol says that in order to mint Go against your collateral, it has to have a value greater than $1. And this is essentially the collateral side of stability. The second is actually the price which you're actually minting and redeeming Go. And this is not really a set mechanism, but there's a variety of ways that effectively the DAO can use to maintain this peg. And the first is interest rate management. So the idea that in order to set a certain target, the DAO can either raise or lower interest rates in order to incentivize minting or redemption. The second is incentivizing liquidity, or like the strategy that the DAO most commonly uses is coordinating liquidity. So basically providing on the governance forum resources for people to know here are the places where Go liquidity currently exists and is able to provide the most stable rate of exchange. And lastly is a peg stability facilitator. This has an asterisk because it is not currently live, but there's an update on the governance forum as of 1 week ago that the peg stability facilitator is an audit. And basically what this is a way to mint and redeem Go at a fixed exchange rate with other tokens. And this is useful not only for maintaining the peg price of Go, but also for a lot of use cases, which we'll touch on in a little bit. So how do you actually, what are the types of applications that you can build with Go or incentivized to build with Go? The first one would be payment applications. As we touched on earlier, almost 90% of the current stablecoin market cap and thus payments utilization is occurring through these centralized stablecoins. And so really incentivizing not only the usage of Go in payments, but also teaching people about why Go is useful for payment applications is definitely an area of building an opportunity. Second would be credit delegation. So credit delegation is a feature of the Aave protocol, which essentially allows one user to take collateral and grant another user the ability to borrow against that collateral. And this is useful for a lot of different use cases. Probably the two most common ones that come to mind are social applications, where essentially one address is able to, perform an action with another address that they trust, a user that they already trust on chain. And then the second is doing this sort of in autonomous systems, where essentially a user is delegating their credit to a smart contract, and then that smart contract decides, when to borrow for the user, and provides basically a way for users to get yield by using their unused borrowing power. And this is something that has currently existed. One of the first implementations was with a Wiren vault, which essentially allowed the users to delegate their credit to the smart contract, and then the smart contract was able to perform these actions. And then kind of a shared feature between these two, payments and credit delegation, things which Go enables and also the Aave protocol enables are methods using signatures. So the ability to abstract gas costs away from an end user is extremely powerful when it comes to especially onboarding new users. If you're building a payment application, you really don't want to have to teach users how to create a wallet and how to fund the wallet with ETH and pay for these transaction gas costs and teach them all of the nuances. And so by using these signature methods, permit is the ability to transfer tokens via signature, approve transfer of tokens via signature, and then second, the approved delegation is how you grant a credit delegation allowance to another address with signature. And both of these are ways that you can abstract kind of the Web3 aspect or abstract the gas cost aspect of Web3 from the end user. And the last thing that I'll mention is visualizations. These are extremely powerful for two reasons. Because the Aave protocol and Go as a subset of that are predictable and verifiable. And what this means is that when you're doing a transaction with Go, or when you have Go inside of your wallet, the things which are occurring to that position are actually written inside of code. So as a user, I am able to know exactly what is going to happen based off of the current DAO parameters and my current position. And so building visualizations, I think, is a very untapped area within DeFi and Aave and Go specifically, just informing users about exactly what is happening when they perform these actions. So specifically within the ETHGlobal New York Hackathon, we've kept the prizes pretty open-ended in an effort to not streamline exactly what people are building. It's very open-ended, so feel free to innovate, and a lot of different things, not just the things which are covered in this presentation, fall under these categories of best uses of Go and the best Aave protocol integrations. And the last thing that I'll leave you with is a link tree where you can find a ton of different resources about Aave and Go. And the two specific things which I'd like to highlight are the Aave address book. A lot of times, a lot of the pain points of integrating DeFi protocols is making sure you have the right addresses, especially if you're working on multiple networks. And what this address book allows you to do is import addresses directly inside of your JavaScript or Solidity code. So instead of copying and pasting addresses, you can import Aave v3 Ethereum and have all of the addresses right there inside of an object. And then second is the Aave Utilities SDK. This SDK has two main functions. The first one is to read data from the protocol, so querying on-chain. And the second is it provides very useful methods for actually submitting transactions. So instead of having to find ABIs, find these contract methods, this provides a very streamlined example for how to do that. And lastly, I'll mention for both of these, you can actually refer to the open source Aave codebase. It uses both of these and is also just a great reference for how to actually interact with the Aave protocol. And yeah, with that, that is the end of the presentation.
Hi everyone, my name is Nick. I'm a software developer from 1inch. And today I want to talk about 1inch Developer Portal. And before that, let's do some small recap. Maybe someone don't know what is 1inch. And I just want to say, that 1inch started at Ethereum New York 4 years ago as a hackathon project. And I was there as well, like at the sitting with the same table with the co-founders. They're not here right now, but they're always happy to support ETHGlobal and every hackathon of developers. And over the last 4 years, we have right now about 4 million users. We have 55 billions of total available liquidity for traders. We have more than 350 billions of dollars of volume. And we have about 70% of aggregation market share right now. Yeah. And over these years, we developed several protocols and services for developers. The main one is aggregation protocol, of course. We do have a limit order protocol as well. We do have a 1inch Fusion, the latest, our invention that allows you to trade with Dutch auction enabled. And also we do have a non-custodial DeFi wallet available for all mobile platforms. And we do also have a developer portal, what I will be talking about right now. So, small recap about aggregation protocol. So, aggregation protocol allows you to make a swap with Uniswap-like experience, but inside one atomic transaction with the best rates on the market. Even if you're doing that with API or with user interface, it's still the best solution on the market right now, according to analytics that we have here as well. 1inch always have open source and traceable analytics over all protocols, but you can also always check this out, what numbers do we have, by just checking june.com/1inch. So, okay, let's start. Actually, recently we considered how can we help builders to continue building on us? Maybe what else we can provide for developers to simplify the experience they have with 1inch. And we decided that maybe it's a good idea to build a developer portal. Actually, it's a combo of all solutions that we have right now. We have multiple APIs that are not available publicly for the hackers, but right now we opened most of them. And with Developer Portal currently, you can use almost anything that 1inch have developed for years for our non-custodial wallet and for our D app. And of course, we do have aggregation protocol and limit order protocol and Fusion available there as well. So it looks basically like that. If you want to try it out, I will have a link soon. And the only requirement for you is just to have a registration. And by default, you will have an authentication token that will be having a limit of 1 RPS per second. And you can freely use any API that is available there with documentation portal. For example, if you will try to use aggregation protocol, I just wanted to recap how it works. The basic integration is pretty simple. You do have two handles that you need to quote to make a transaction. First, you need to make a quote, to call a quote handle with 3 parameters: from token amount, to token amount, and address and amount of the token that you want to swap. If you're okay with the returned amount that you will get, basically you need to continue and call another quote called swap that will actually build a call data that you will need to execute on your own address, on your own wallet, by calling the 1-inch router smart contract directly. So you can try aggregation protocol via the 1-inch developer portal instantly right now. If you want to check it out, there is a shortcut for it. And I just want to show how it looks like and how you can try it out right now. So basically this is actually the developer portal that we have right now. And I want to try to use aggregation protocol, just basic quote and swap handle with you. So we have a documentation tab. Let's wait until it will be uploaded. 1 second. Oh, sorry. Have small issue, sorry, with the display. 1 second. Sorry, may I ask you for support? Yeah, looks like. I can't mirror this screen. I need to mirror the screens, and it doesn't mirror, even if I use it as a mirror screen. Okay.
Never
Great.
done that before.
Thank you. Sorry for that. I'm sorry for the delay. So let's continue. So let's try to play with some APIs that we have on developer portal. Firstly, on the website directly. So for that, we basically don't need anything except have been registered on developer portal already. And we do have a Swagger here. Let's wait until it will be downloaded. So we do have multiple handles there, but this is the main 2 handles that you need to use if you want to play with aggregation protocol. The first one basically allows you to get a quote, so let's execute it. In this example, we will have a native token swap rate to the 1-inch token with the amount of, I think, 0.1 Ethereum. So let's take a look what will be the rate, the token amount that we will have. Okay, we got it. So this is the 2 amount that we have for the 1-inch token. We can actually calculate what will be the return if we'll just make it not in the VE amount, but in the human readable amount. 1 second. Okay, looks like internet doesn't want to be my friend today. Okay, let's continue on other APIs that we have on developer portal. So adding an API, we added much more APIs to developer portal compared to aggregation protocol. And the next interesting one is actually spot price API. And this API allows you to get any token to native token and to USD and any other fiat currency price rate. And you will get it in the batched amount. So the problem that we want to solve actually is that we need to get somehow we need to get rates, fiat rates of almost every token that we have on the market to basically, users always compare any amount to the fiat amount, and we need to get updated prices of them. And if you'll try to use Pathfinder in such case, it will be very resourceful, but we still need to use something for that. The problems that we have is that it must be really up-to-date, because if it will be not up-to-date, during one block transaction, the price can significantly change, and in such case, users can lose money. And a user can't make a trade in such case, for example. And this API is actually used almost everywhere on our front end, on our D app, on our wallet. And what this allows you to do is basically get price of almost any bunch of tokens, almost with the real-time precision. And it's actually based on open source of spot price oracle that is available on our GitHub. Our spot price oracle actually allows you to get fiat, like native token price of any token based on smart contract that actually aggregates the prices of every Uniswap pool that is available for any token on multiple networks or Uniswap-like protocols. So you got pretty transparent pricing model for every token that you need to get a price. One more API that we have there is a balances API. We also widely use it everywhere. The main feature of the balances API is that you don't need to call Node-RPC directly, and you can use batched requests. So basically, you don't need to make 1,000 requests per 1,000 tokens. You just need to make one request, and we will do all for you. We're using OneInch multi-call operation there, and it's pretty easily available on OneInch developer portal, so you don't need to care about other Node-RPC services. For example, if your app have a cross-chain support, you need to take care about every chain Node-RPC, and it's quite resourceful. On developer portal, you can just use it and just change the parameter of the request. So yeah, multi-chain, low latency, and one API call for getting all the balances and allowances at the same time. And one more pretty simple and nice API that we have, it's called Token API that allows you to search over tokens by querying. So basically you have a text search over all your ERC20 tokens over all networks that we do support. It's about 11 EVM networks right now. And also you can get images and everything that you need to display for user as a for the tokens. We use it on the front end on our D app as well. And we do also support the Uniswap token list standard, so we do aggregate multiple providers of tokens. So if you want to switch between multiple providers of Uniswap token list, you can make it with this API. And we do have a small rating system inside. So when you do a search, we actually provide a filtering, and we provide like search depends on the rating of this token, and the rating of this token is actually amount of Uniswap token lists where this token is actually available. So that means that if we, for example, searching for Aave token, this token is quite popular and it's almost available on every token list. So it will be in the top of the results. And last but not least, we have a portfolio API. Its API allows you to get your trading portfolio with TVL, with a lot of new features. Is some small pre-release that we will have soon. The best of it is that we have a fantastic charts for any token to any other token in multiple networks with very nice precision and granularity. All the data is taken from on-chain, so basically it's pretty accountable. And right now I have a small examples, 101s, how you can run all these APIs on with your node, with your code, using Node.js, for example. So this is the link for the OneInch developer portal 101. If you want to try it later on your own, just download this repo, and there are only 2 requirements that you need to have there to run it. It's basically, it's available in the config. The only 2 requirements to run it is to have your private key available for the swaps, if you want to make a swaps, and authorization key available. Authorization key is free, so you can get it on developer portal, and the private key, I think you know what is it. So let's play a bit. So I decided to make some user flow with all our APIs, how we can build a small D app. I am a backend developer, so I decided to skip on front-end part. So let's trust OpenAI and someone else to build a front-end later. So let's imagine that we have a user that is trying to search something over like our input, so for some tokens. Let it be, for example, OneInch, because they just somehow went to OneInch website. So let's try to run a search using tokens API for the search. And yeah, I will check out what will be the result. So we have a search result here for the tokens of 1 inch. So as you can see, the 1 inch token is on the top list, so we have some sort of it. So like sorting of every token based on your text query. And basically, I made a wrapper over our APIs. If you want to see how it works, it's pretty simple. It's basically HTTP requests and almost nothing else. It's pretty as simple as I can. It's really hard to imagine how even more simple it can be. It's basically API requests to our developer portal with basically passing the parameters that you have from the Swagger. In such cases, just passing the query for the text and also chain ID. I made it a bit simple, so if you want to try to use anything of that, you can just copy these functions, and that's almost it what you need to use this API. So as you can see, we have some search result of 1 inch tokens, and just wanted to demonstrate that right now you can get not only we can take a look on 1 inch token what is inside. So we have name, symbol, log URI, so you can display a picture on your front ends, for example, and we have a list of providers. So providers are actually token lists that are available with such token have. And we can see that we have a 1 inch token list at the top of it. So let's try to continue and grab a token list of some providers. In such case, let it be a 1 inch token list. So I already make this request. So let's wait until we will get a token list of 1 inch. And here we are. We have a token list by provider. This token list is the standard token list by standard of Uniswap. So you have a group of tokens. It's about 1,000 tokens that 1 inch does support on the interface by default. And let's imagine our user right now sees a lot of tokens. So user wants to get information, what is the price of some tokens here. Let's imagine that our user picks some of these addresses and want to get a fiat price of these tokens. So for that, we will need a spot price API. Let's try to run it. And this is like basically the example how you can run a spot price API. It's almost as simple as token API. So basically, it's a wrapper over one get method that allows you just to pass a list of tokens, and versus currency, you want to get the rates. So in our case, it will be some tokens from 1 inch token list. So let's try to run it. I'm sorry. Let me turn off the tokens part. Oops. Oh, debugger, something goes wrong with the debugger. Let me just play it so I will get logs of it. So here we are. We do have actually the prices returned for this bunch of tokens. And this is actually the fiat prices of these tokens. Basically, OK, user actually right now knows about our USD prices. And let's imagine that our user wants to continue on this deep research. And if no user get interested in one of them and want to get a historical price of some tokens by using a chart API. So let's try to get the chart, a historical chart of some token versus USD to make a technical analysis search, for example, for such user. And in such case, we will use charts API, basically. And it comes from Portfolio API. I will show you a wrapper over it. It's almost as simple as everything else. So it's here. And the only requirements here is just chain ID, token, and versus currency. It's almost simple as everything else. So let's try to use a chart API right now to get some information about historical prices of this token that user already found. Okay, so we have some candles. I don't want to visualize that via the console, but as you can see, we have some price movements here. And let's imagine that our user right now do perform very nice productive technical analysis, and this user wants to trade this token via one inch API. And let's try to trade this token. So to make it possible to make a trade, we will need to use aggregation API. And to make, so for that, we firstly need to have some preparations. So before we will make some preparations, we need firstly to get our balances. So we need to understand what is our balances on our address that we have from the user. And for that, we will use balances API. The balances API is also simple as everything else to use. The only difference here between these two wrappers is that you can either have balances and allowances together, batched via one call. So you just pass address and list of tokens, and you will get allowances and balances of every token for this address with the spender on it. If you will also pass a spender for such for allowances. In our case, it will be one inch token address, one inch router address. So before we'll try to perform a swap, we will firstly need to make approval on the one inch router smart contract. And if you want to make approval, you first need to check that the user needs to have some approval. Like, does user already have approval or not? So let's check that we have some approval on it or not. I will use a get balances and allowances, and in my case, I will have one inch router smart contract as a spender, address of my private key that I have in the env variables, and the network will be actually Ethereum network. Authorization key I have in the config, and we will try to get balances and allowances of several tokens. It will be one inch token. It will be USDC coin. It's the same on Binance Smart Chain and Ethereum, so I just hard-coded it for the Binance Smart Chain here. Sorry for the naming, and for the wrapped Ethereum token. So let's execute the balances here. 1 second. Okay, so we have a balances. As you can see, it's a key value result. And for the one inch token, we have a balance this one, and we have this one allowance. So it looks like it's okay, and we potentially, for example, can trade from one inch token to any other token, and we already have allowance for this address. If we don't have it, I also do have a script here nearby to make a proof. It's just below here, and I think I will skip it for now because I want to continue on other interesting APIs. But if you want to try to use it, you can just use it with arguments true. So let's try to make firstly a quote, and if the quote will be okay for us, we will make a swap from one inch token to, for example, let it be the wrapped Ethereum token that user actually was doing research. Okay. Okay, let's try to perform a swap. I don't have I'm a bit out of time, so let me just to continue to the swap with this API. So we just perform it. So in our case, we will try to swap 10 one inch tokens to some amount of wrapped Ethereum. Let's imagine we already quoted the quote API and we got some results. So this is a transaction hash that we have. Let's check that we have it open, like we have this transaction on Etherscan. So here we are. We try to use aggregation router API to swap some one inch tokens. Let's wait until it will be executed. Basically, you can see the information about the swap here. Oh, I think my transaction stuck a bit. But one more point, when transaction will be executed, we already have a transaction hash. And what if I want to get more information about my transaction hash, like how it was executed? For such thing, we can continue to use one inch API and use one inch tracers API. And using one inch tracers API, we will get information about the trace, about all events, about all logs, calls, everything potentially that you need to debug and analyze the transaction. You can build almost anything on that. If you are familiar with transaction traces, you know that it's extremely hard to get traces of almost any transaction, of almost any block. And Managed Developer Portal provides traces API that will have almost zero latency, and it will be extremely reliable and fast to get traces of almost any block from Genesis to the current one for multiple chains, for 8 EVM chains. So I don't have enough time to wait for the transaction to be executed, so let me just show you an example how the trace looks like, and I'll finish. So as you can see, the block trace is something like that. It's basically the transaction trace, not the block trace, but you can also use a block trace in such case. And we do have a calls here that allows us actually to see information how our transaction was executed, what was the storage operations here, and using all of this data, basically it's much more easier to build analytics. And basically, using transaction traces API, you can build your own indexer, and the only requirement for you is just using traces API instead of running your own archival node, which is much more easier, especially for the L2s. So I think that's it. So thank you for your attention.
All right. Hi, everyone. I'm Ian Dillick. I lead developer relations at WorldCoin, and I'm here to tell you about World ID, our global proof of personhood protocol. I will try to keep this to within 20 minutes so we can get back on track in here. So what I'll go over in this workshop, what World ID is, why WorldCoin created it, what you can do with World ID, and most importantly, how to integrate it. It's quite simple, actually. So WorldCoin sort of big question that we're answering with World ID is, how do you know who or what is a real and unique person, right? You want to know that your user isn't a bot, and you want to know that they're only getting to do something once. World ID helps with both of those. So World ID, just a couple months ago, became publicly available. Before that, it was on a wait list, but thankfully that's gone. And World ID is designed to be private, inclusive, and robust, right? We want to collect as little information as possible about who you are. We want as many people as possible to be able to participate in this system. And we want to make sure that each person can only have one World ID. So we looked at a bunch of different ways that we could actually get that information about you being a unique human, right? We looked at verifying with an email or phone, but those really aren't robust. I have multiple emails, I have multiple phone numbers. Breaks that tenet. We looked at doing KYC of official government IDs, but less than half of the global population has a digitally verifiable ID, so that's not inclusive enough for us. We looked at web of trust systems, but they really don't scale to all of humanity super well. If you start with an initial verified set of 100 or even 1,000 people, you have to be many hops away from that initial set in order to verify, say, 1 billion people. And every hop away from that initial trusted set you are is really the less trusted you are. So we settled on biometrics, which initially sounds a little bit scary, but it is something that you can actually do in a privacy-preserving way. And when it comes to which biometrics we use, we looked at fingerprints, face scans, palm scans, but none of those actually have enough entropy to distinguish, between billions of people. Face ID and Touch ID on your iPhone can distinguish about 1 in 30 million people. That works fine for making sure that you are the same one person who set up Face ID on that phone, right? If you're one of the 12 people in the US who could steal my phone and unlock it with Face ID, you know what? More power to you. We also looked at DNA, an incredibly high level of entropy, also incredibly invasive. It's impossible to not know a lot about that person if you have their DNA. So we settled on iris biometrics because it doesn't tell much about who you are, but there is an incredibly high level of entropy, so it can actually be used to distinguish between people at the scale of all of humanity, right? Even identical twins have very different irises. And when it comes to how we do those iris scans, we looked at using users' phones. But the issue is that the resolution on the cameras there isn't high enough to capture that level of entropy that we need to distinguish billions of people. We looked at off-the-shelf hardware, like what they use for Clear at airports in the US, but it's really expensive. Also is used for one-to-one, right? Are you the same person as your ID versus, are you unique from billions of other people? So we settled on building custom hardware. And that hardware is the Orb. You might have seen them at our booth. You might have heard about them before. So the Orb's been in development since early 2020, gone through lots of different revisions, and is also, the hardware's 95% open source. We haven't open sourced the hardware for tamper resistance and security for hopefully clear reasons, but all the rest of the hardware you can go look at on our GitHub right now if you're someone into hardware like that. So the Orb, first, make sure that you're actually a human, not a photo of a human, not a cat or a dog. Takes photos of your irises, calculates this iris code, so a non-reversible digital representation of the pattern of your iris. If you don't opt into data custody, we never store those images that the Orb takes. They get deleted from memory on the Orb. They don't even touch its storage. And then we use that iris code, check to make sure it's unique from all the other iris codes of everyone else who's signed up at the Orb before, and with that we verify your World ID. The public key of your self-custodial identity in World App gets added to a Merkle tree on chain. And I'll talk a little bit more about how that actually makes World ID this proof of personhood protocol. That's everything the Orb does. World ID is designed to be privacy first, decentralized, and open source. So again, we don't ask your name, your email, your address, your ID, anything like that. We ask your phone number, but that's optional. It is decentralizing, right? We have the WorldCoin Foundation that stewards this protocol. Right now, the Orb is the one device that you can use for verifying at the highest level with World ID, but we are exploring other verification methods, and those may even come from other companies. And it's open source. All of our smart contracts, our sign-up sequencer, everything like that is on GitHub. You can go deploy your own if you'd like. World ID has lots of different use cases, right? Voting is one that makes a lot of sense. You want to know that the person voting is actually a human and not a bot, and that they only get to vote once on each proposal. And as an added bonus, you can't correlate 2 different votes on 2 different proposals back to the same person. So it helps with that privacy aspect, right? Social media, again, you want to know that it's not a bot. Customer incentives is one that I find particularly interesting. Maybe you want to give your user a sign-up discount, but sometimes with sign-up discounts, users get them more than once. I know I've spun up multiple emails to get a bunch of those 2-week free trials on Netflix. But if they used World ID, maybe they'd be willing to give you a 3-month free trial because they know you're getting that free trial only one time. And we've also designed World ID to be super, super easy to integrate. You can use it on the web, on mobile, and on chain. There's 2 main ways to integrate World ID, and the first and the easiest is sign in with WorldCoin. So let's see what it's like to use sign in with WorldCoin. We actually use sign in with WorldCoin for logging into our developer portal. So I'll go ahead and show what that looks like now. So when I hit login, it takes me to this page with a QR code. I can scan this from within World App, or I can even just scan it with my phone's camera and it will automatically direct me into the app. sees, okay, it wants me to sign in with World ID for the developer portal. I tap verify with World ID, does a little Face ID check. Oh, it didn't work because I had been waiting on the page too long. I promise this works. I just had that page open for like half an hour before this. Verify with World ID, do the Face ID check. And now I'm logged into our developer portal. So any of you who are building on World ID will need to log into this developer portal. You can add a new app, give it a name, select staging or production. If you choose staging, you have to use the WorldCoin simulator, which I'll show you in a little bit. If you choose production, users have to use the World app. And then you can also choose cloud or on-chain, and again, I'll talk about that in a little bit. But developer portal is pretty simple, and it's a really simple flow for sign-in with World ID. And there's lots of different ways you can actually integrate sign-in with WorldCoin into your app. We have an integration with Auth0 if your app already uses that for sign-in. Nextauth.js, we have a template repository for that one that makes it super simple. You can use our OIDC well-known file with any other OpenID Connect library. You can custom implement OpenID Connect flows. But I'll walk through how you can do it with nextauth.js. This is all it takes to integrate sign-in with WorldCoin if you use nextauth.js. This is the file for configuring nextauth.js. We set up a provider for WorldCoin. We pass it that well-known file that tells it all of the configuration parameters it needs. You have to set the client ID and client secret that you get from the developer portal in your environment variables. And then we assign the nullifier hash that you'll get back from World ID as the unique ID for that user, and the credential type, whether they are phone or orb verified. Those are the two credentials available in World ID. Phone being much, much weaker. They've verified their phone number in World app. Your app doesn't get to know that phone number because of the zero-knowledge proof system we use. It's to preserve the user's privacy. Or they're verified at the orb. So to use anonymous actions, which are quite a bit more powerful and more configurable, there's a little bit more complexity, but it's still really simple. Using anonymous actions, you can know that your user is a unique human doing something once, or an arbitrary number of however many times you want to limit them to doing it, with a specific signal. That signal is optional, but that's an extra bit of information that can be encoded into the zero-knowledge proof so that you know it's not tampered with. For example, that signal for claiming an airdrop would be the address that that airdrop is being sent to. Or if it's a voting situation, that signal would be which choice they're actually voting for in that proposal. And the basic flow for anonymous actions is that the user scans that QR code from our front-end widget. User generates the proof on their device, and then your app has to verify that proof, either with our API or on-chain. And I walk through the front-end widget and how you can verify both with the API and on-chain. But it's important to note, you have to verify the proof. I'll reiterate it again later, but that's an essential step here. So let's see a quick demo of what using anonymous actions looks like. And this is where I will also introduce you to the simulator. So on our docs page, we do have a little try it out section as a demonstrator. So for anonymous actions, I'll choose staging, so I can use the simulator here at simulator.worldcoin.org. Looks pretty similar to World app. We'll just leave this at test action for the action name, and we'll only accept orb credentials. So I click continue with WorldCoin, and the ID kit widget pops up. And it takes a minute to load this QR code. I'll reload the page real quick. Because again, sometimes things are a little bit slow, and I'm tethering to my phone for internet right now. There we go. Let's try this again. Staging, test action, sure. Continue with WorldCoin. So, pops this up. If I'm using World app as like an actual end user, I would scan this QR code with my phone. For the simulator, you can either run the simulator on your phone, just in the mobile browser, and you can also scan it with the camera just like you would in World app. Or if you want to run the simulator on your laptop or desktop like I am now, you can actually just click the QR code in IDKit to copy that information. So hit scan QR, paste data. I'll go to manual input since I'm on the computer. I paste in everything that got copied from the QR code and hit submit. All right, so because I'm in the simulator, I can select which credentials I want to allow. Click Verify with World ID, and the proof was successful. And if I actually look at the console here, you can see what gets returned from IDKit. And again, I'll talk a little bit more about that in 1 second. So with IDKit, it's one React component. You can also use it with Vanilla.js. That is described more in our documentation. So you have to provide it a couple parameters. One is the action, so the name of the action that you've configured in our developer portal. OnSuccess and handle verify are two callback functions. Handle verify is optional, but it runs while IDKit is still showing a sort of pending state after the user has generated that proof on their device and sent it back to your app. OnSuccess runs after the modal has closed. App ID, again, that's from your developer portal. Credential types, you can also just leave that blank. It defaults to only orb, but you get to pick which credential types you want to actually accept. It also needs a child component that is, typically just going to be a button that will open this widget. So this response that we saw in the console on the try it out page of the developer or of our documentation, this is what gets sent as an input to the two callback functions, handle verify and onSuccess. So we have the Merkle root, which is the root of the Merkle tree that this proof has to be verified against. The nullifier hash is the unique identifier of your user in the context of that specific app and action. So if that app ID and action name are the same user will always generate the same nullifier hash. But if that action name changes or the app changes, then user will always have a different nullifier hash. That helps preserve their privacy, prevents tracking that user across multiple actions, but that nullifier hash is also what we use for Sybil resistance, because if that user tries to do the same thing twice, we know we've already seen that nullifier hash. The proof is the super long hexadecimal string that actually is like the zero knowledge proof that we do all the fancy math to verify. And finally, you get the credential type that that user is verified with, in this situation, just orb. So we have to verify the proof. Just receiving that back from the widget doesn't mean anything. Any information that's just in the front end like that, your user can manipulate. And if you don't verify that proof, either with our API or on chain, you don't actually know if the user is a unique human or not. Your project is not eligible for bounties from WorldCoin if you don't verify that proof. You have to implement this properly. Verifying the proof is important. I cannot reiterate that enough. So if you want to verify that proof with our API, then it's quite simple. The base URL would be developer.worldcoin.org/API/v1/verify/your-app-ID. That is the endpoint for proof verification. So you send it a post request with the body basically being what you got back from IDKit, that thing right here, plus information about your app ID and action name and the signal if that was used as well. So you should first send that information to your backend, and then your backend should call this API endpoint. And if you get a 200 response, great. You know that user is a unique human. They're doing this thing within the limited number of times you've set in the developer portal. For API verification apps, ones where you selected cloud in the developer portal, there's a drop down and you can select how many times you want to let them do that action. And yeah, otherwise there will be an error. We'll have some description of what the error actually is, whether that the proof didn't verify correctly or that the user has already performed this action. And again, there's more detail in our documentation at docs.worldcoin.org. So after you've gotten that 200 response, still in your backend, that's where you should do something like setting your user as verified in a database, right? Do that thing in the protected environment that you control rather than from the front end. If you want to verify a proof on chain, it's a little bit more complex, but still really simple. In the constructor, we set the world ID, which is the address of the world ID router contract. We have an address book in our documentation. Make sure you use the relevant address for your chain. In terms of chains, we support Ethereum, Optimism, and Polygon, both on mainnet and testnet, Gurley, and Mumbai. And additionally, we support base Gurley for testnets as well. So in this example, we're just doing a single action. So we set this stuff in the constructor. The external nullifier is essentially just the app ID and action ID shoved together. This proof verification system is built on Semaphore, so external nullifier is the terminology they use. And then in this function verify and execute, we would verify this proof and then immediately after do something like minting an NFT to that user, for example. So in this situation, we use the signal as the address to, or hypothetically, we could use the signal as the address to mint those tokens to. The first thing we do in this function is check if we've seen this nullifier hash before. One thing I left out in the earlier slide was defining the mapping of nullifier hashes, where if you set it to true, you've seen that nullifier hash before. So first thing we do is check if we've seen it before. If we have, revert. Then we try to verify the proof. We include that signal. The group ID for verify proof is going to be 1 for orb verifications. We don't support the phone credential on chain, so you can hard code that to 1 in your contract with no issues. And then the rest of the information is what we received from IDKit. If that proof doesn't verify for whatever reason, right, that will revert and the transaction won't continue. So if that doesn't revert, immediately after that, we should go ahead and set that nullifier hash to true so that we track that we've seen that nullifier hash before, right? The one big difference between API verification and on-chain verification is that for on-chain verification, you have to implement the Sybil resistance part of it yourself. That is why we're tracking the nullifier hashes here. It's very important you do that if you want Sybil resistance. We can do that for you with the API verification. We can't do that for you for on-chain verification. Finally, after we've set that nullifier hash as true to know that we're tracking it, go ahead and do whatever else you want. So we have 20K worth of bounties, 5K to best overall, 2,500 each to best governance app, most creative, best AI use case, best sign-in with WorldCoin app, $2,000 to $1,000 honorable mentions, and a $3,000 prize pool for every project that properly integrates World ID, whether that's sign-in or anonymous actions, and doesn't receive another prize. And let's build together. If you go to WorldCoin, thank you. If you go to worldcoin.org/NYC23, you'll find a Notion page with a lot of the information contained here, information on our bounties, a ton of resources, links to our documentation, developer portal, template repositories, everything like that. And if you have any other questions or want to get verified at the orb, come find our booth. It's like all the way in the back corner. Thank you all.
Fine. Yeah. All right. Hi, everyone. Hello, GM. My name is Tony Orlando. I am a developer relations engineer at Polygon, and developer relations engineer at Polygon, and I lead the developer education team. And today I'm here to talk to you about the exciting concept of self-sovereign identity and Polygon ID, and specifically introduce to you like what Polygon ID looks like, and show like the intersection of Polygon ID and Lens, essentially, because one of the most powerful use cases of identity is in social media. And so imagine if you could like verifiably discover who that troll was. Polygon ID would actually enable you to be able to track them down, like Liam Neeson would like you to, right? So how do we get started with Polygon ID? Let's first define it. Polygon ID is essentially a tool that uses zero-knowledge proofs to let a user prove their identity without exposing the private information, right? Which is a really important concept. But when you look at it practically, it means that I could attest to my job history, and I could say, yeah, so my name is Tony. I've worked at Polygon Labs since that date, and previously I worked at Coordinape, shout out Coordinape, up until that date. And so from there I could like state like, I could define a schema for my data and say, I want to store data for everybody who uses my system, and be able to define like the name of the organization that employed them, the role that they had, whether or not it was technical or not, and the start date, right? But I could also use it to define simple things like even like a data schema that just defines whether or not I have a dog. And I could define whether or not I have a dog, if I have a cat, and then the total number of pets I have, right? So, and this is a picture of my dog. So I could define, yeah, pet ownership. Yes, I have a dog. No, I do not have cats, because cats are evil. And I have one pet, right? So how do we know these claims are true, right? So we need somebody to be able to actually attest and say, well, do we have a third party or somebody who could like authoritatively say that, yeah, I do work at Polygon. How about Polygon HR or HR Coordinate? You know, so we could actually find a source of truth that we could use to be able to attest to this information. And what that is, that the attestation is called a verifiable credential, or a VC, and it means that basically that you could have one or more claims that are made by a trusted issuer. So say when you start a new job and somebody has to go and like call your old job and be able to say, well, did Kim actually work here? And you could be able to say, yeah, Kim actually worked here. And then that person leaves with the definitive trust that, yeah, you actually did work there, and they could actually attest to your particular employment history that you defined. But if you're gonna define it like technically, essentially, a verifiable credential is basically composed of two things. One is a claim, which is a basic assertion made about a particular subject, and then the credential is essentially a set of one or more claims that are made by an issuer. And so a verifiable credential is a tamper-evident credential that has authorship that can be cryptographically verified. And so when we actually issue a verifiable credential, this is what it would potentially look like, right? So if we have this verifiable credential that is like a job-held credential where I could say, well, this is who employed me, this is whether or not I had a technical role, and this is a start date, that essentially forms a schema. And then if we have communication and contact with your previous employers, we could actually authoritatively state, yeah, you were employed by Polygon Labs and you were also employed by Coordinate, right? But then I can't really, my dog can't attest for itself and say, yeah, it actually worked at NASA or something of that sort. Like, it doesn't necessarily work that way, right? So you need to find an actual authority that could actually become an issuer of said verifiable credentials. But at the end of this, at the end of all of this, we've introduced a couple of different concepts. All of them are really important, but the main thing to remember is that when we're looking at like decentralized identity and verifiable credentials, they essentially comprise of three primary actors, right? So you have an issuer. An issuer could be you, could be a DMV, it could be the university you went to, it could be the college you went to, it could be any government body, and basically they are the ones who could make attestations about you as a subject or any other subject that you're actually dealing with. And then you have an identity holder, who is me and you, so you and I have an identity, and the identity holder holds these are particular claims or verifiable credentials inside of a wallet. And using that wallet, I can now present the verifiable credentials using zero knowledge to a verifier. And the most significant piece of that is that you could imagine if you're going to buy alcohol and you have a verifiable credential of your birth date, then you could actually just present just whether or not you're actually above 21 without necessarily revealing your actual birth date. So that's one of the easiest and simpler ways of looking at it. But if you look at it in practice, I could actually have my former manager, Liam, at Coordinate issue me a verifiable credential using the schema that we actually defined. And the schema has about 3 different claims. The name of my former employer, whether or not I had a technical role, and my start date. And using a zero knowledge proof, I can now present that information to a particular issuer, and the issuer doesn't need to know the full details. All they would need to know is whether or not I had a technical role. And we could actually just give them just that succinct piece of information and leave out the name of my previous employer or even my start date. So that's the kind of flexibility that we would see when we're looking at self-sovereign solutions, self-sovereign identity solutions such as Polygon ID and others. But let's just kind of expand this to a concept that I guess we actually mostly familiar with, at least I hope, right? In a room of people of culture. So I imagine everybody knows Harry Potter, right? Yeah, but basically you could think of like the issue example being like the sorting hat that would essentially issue Harry with a credential that says you are of House Gryffindor. And what that does is that if you actually have that, then the verifier could be like a magic door. And when you go to the magic door, it basically unlocks like the Gryffindor common room. Or it could be the team captain. And because you're of House Gryffindor, you could then be eligible to join the Quidditch team. So those are like a simplified example of how you should actually like conceptualize how you could use Polygon ID in the absolutely real world that is the Harry Potter universe, right? Because it exists. So let's just break down further like the components of this. We have the Polygon ID wallet that basically holds your verifiable credentials. It basically, and what it does is that it does three primary things. It holds your verifiable credentials. It also interacts with an issuer who basically fetches and stores verifiable credentials, and it also interacts with a verifier to share zero knowledge proofs based on said verifiable credentials, right? So this is what it looks like when a credential is issued. You start off the process with the offer, and then the claim is added, and it now exists Polygon at the pit. And when you open the verifiable credentials, you could see various claims inside of it that are like whether or not you're allowed at the pit, the number of projects built, the date it was issued, the DID of the issuer, whether or not it's expired, and signature, the type of proof. I won't go into signature proofs in this particular talk, but that's essentially what it looks like. And verification is fairly simple. You would basically open up your Polygon ID wallet and scan a QR code that would be used to verify. And from there, you would like generate a proof internally and make that available, and whether or not you actually have access to whatever VC-gated tool you're looking at, you would then be given access, right? So that's the standard workflow in the context of verification. But let's talk about Lens, right? Which is the fun thing. That's why most of you came, I imagine. Yeah, so Lens protocol is basically a Web3 social graph built on the Polygon proof of stake blockchain for now. And when we look at Lens, I'm going to go through so I'll start off this presentation because we all know how great conference Wi-Fi is. I pre-recorded this just to ensure that we have a consistent experience, but this is an example that shows the workflow of how you would use an issuer to build a front end that issues credentials based on your Lens profile, right? So you start off here where you have the Lens application. So you first of all log into Lens, and as you can see, it signs the transaction and gives you all that information. And once you connect, boom, you're in. So it has your bio information, the number of followers, and the people who are following you. And then we create an issuer, which is the first step of this. And then the issuer will then create a so at this stage, I'll just explain what's happening here. So first of all, we actually create an issuer. So your app becomes an issuer that issues credentials, right? So you could think of it like a Lens issuer that you actually created in this stage. And then from here, the user will then enter their DID from their Polygon wallet. And once they enter their DID, it generates a QR code. And they have a QR code. So now we have a verifiable credential that we are using to prove the number of followers that you actually have, right? So if you scan this piece of information, well, if you scan the QR code, it would automatically add a verifiable credential to your Polygon ID wallet with the schema that we actually defined. So why is this useful? It actually provides a greater degree of trust. And the number of followers example isn't meant to be the absolute killer compelling use case, but a really good demo of what it looks like for you to consume data from the Lens API, stick it into a verifiable credential, and issue it to a user who will then hold it inside of their wallet. So let's go through the process of what this looks like. I have the sample code is available there. You could actually go through and look at it from the beginning to the end. It shows the entire life cycle from when you start off from getting from logging into Lens all the way through to issuing the QR code. And there's a dependency on QR.io there that I'm hoping that we'll be able to figure out how to manage and mitigate in the initial instance, but it should be easy for you to do. So what does the process look like? First of all, we set up an issuer node, and then we create an issuer, and then we design a schema. After we design a schema, we query the Lens API, and then we issue a verifiable credential. It's easy, right? Easy. But let's go through it step by step. These are the things that you'll have to do once. So you need to set up your issuer node that you only need to do once. You need to create an issuer that, again, you also need to do once and store your issuer DID. And DID is your decentralized identifier or identity. You need to design a schema that essentially is the shape of the data that you want to send to the user's Polygon ID wallet. And then from there, you could when a new Lens user comes to your dApp, they could essentially query. You could actually have them log in, and you query the Lens API, and you're issuing a verifiable credential all day, right? So first of all, you start off with the issuer node setup. So this is where you actually go to set up the issuer node. This on the left is your code, and the docs on the right. I'm not sure if it's your left or my left. I'm left-handed, so I always compensate and I get things wrong. It makes driving around in new cities really, really fun. But anyway, issuer node. This is where you could actually get set up, and I have a tutorial that shows you like a step-by-step guide of getting started with the Polygon issuer node. So you could feel free to watch that. Sorry if the QR codes are coming up really, really quickly. But you can just check out YouTube, Polygon ID issuer node, and it'll take you through the full process. And I think I also have a video aside from that as well. So you've successfully managed to set up your issuer node. What to do, it's probably running on some cloud provider, or you're running it off of your computer locally, or you wrangle the DigitalOcean droplet to be able to do whichever configuration works for you. Then you could create an issuer. So let's go through the process. From a code standpoint, it's really, really straightforward. All you need to do is to send a request to /v1/identities, and you're sending in 3 bits of information. The method, which is the standard like Polygon ID schema that you want to be able to define for your DIDs, which basically is how Polygon ID DIDs are actually defined. You have the blockchain, which is the blockchain that you want to use. You want to use Polygon, and the specific network you want to use is Mumbai. And when you do that, you get a response on the right. Cool. Well, you get a response below where it says response on your screen or wherever you're looking at this from. And the main thing you're looking at is like the identifier, and that's your DID. And the DID is what you want to store. And so now you're able to have an issuer, and that DID is what you would store inside of your database. And every other person who comes who comes to get a VC from you would actually get a verifiable credential backed by this particular DID. So then the beauty of it is that we want to talk about like schemas, which is the final step in terms of like making sure that you're able to actually have a reliable set of data that you could use. So a schema essentially encodes the structure of a particular verifiable credential, and they allow you they allow for interoperable use of VCs across different services. If you have a schema, you could actually combine various schemas during, various verifiable credentials when you're actually doing the verification later on. And the schema components are basically defined on 2 primary things, which is your JSON LD context, which is a description of the type and its fields, and the schema, which contains the validation rules for the specific issuer node. So if you want to build your own schemas, you should check out the schema builder, which is on your left. Boom, I finally got it, right? Like 20 minutes into the talk. But anyway, on your left, the schema builder, really, really good tool for you to be able to understand like what it looks like. So please do not roll your own schemas. Just use the schema builder. It works really, really well. And if you want to understand how to build your custom schemas, you could do that. And it will show you just how to add the bits of information. A small caveat, I'm not sure if that was actually fixed, but sometimes you have to click out of the focus area for you to actually click the button. So it can be a bit frustrating. We are still working on the UX for the schema builder. And next to it, you could see at the very top, you have the query builder as well, which on the verification side, which I'm deliberately not covering on this talk, would actually enable you to actually get started with that. So now you've done all the things you need to do once. So you have a schema, which basically is the shape of your data. You have an issuer, and you set up the issuer node. So let's get to using your actually creating like the VCs. So for this particular example, the top part assumes certain things. That you've gone to Lens and you've gotten a figure for the Lens followers, and you've gotten a figure for the Lens ID. And so what we're essentially doing here is that the schema that I'm using in this example had two primary bits of information that we were storing, Lens followers and Lens ID. And what we're doing, which is really important, and as I would have pointed out earlier, is we're using the ID in the credential subject, and we're actually using the DID that we created for our issuer. So that's your custom issuer, right? So anybody building here will have different DIDs for their personal issuers, and that's what you actually include when you're generating the verifiable credentials. And from there, all you'll get is a claim ID, and once you get the claim ID, you could actually add it to the request. So if you see like the path at the very top, so you have a claim ID, and if you request that, you get a QR code. So this is the body that is basically encrypted in the QR code. So once you actually request this, this is what you get back, and that's what you send to QR.io, and QR.io generates the QR code that is presented to the user, and once the user scans that, it's embedded in their Polygon ID wallet. And that's like the full like workflow of getting from basic to like fully set up to issue credentials. So again, I'll go through my sample application just to hopefully tie the concepts together. You log into Lens, first of all. Once you sign in, we could then query your Lens profile and get bits of information about you. So we have the number of followers you have and who you're following. We take your Lens ID, we create an issuer, and from the issuer we get a DID. The DID is then the user DID, and then we create a verifiable credentials, and we generate a QR code, and boom, the QR code is created, the user scans this, and it enters their wallet. So that's the full workflow of issuance. Again, if you want to look at the sample repo, it's available here for you to actually review. And I'm giving it, oh, okay, one person is scanning. In the meantime, I was actually going to sing while you were presenting, but you actually finished really quickly, so everybody thanks you. This wasn't supposed, oh yeah, sorry. Building a VC-gated app. So if you want to do like a verifier, Steph, who used to be with Polygon, did a really good repo. I mean, like talk and has a really good repo on the verification piece, right? So I've shown you the issuance side, which is all we have time for. If you go back to ETHGlobal, the ETHGlobal YouTube, and you look for a talk titled Building a VC-gated dApp, you'll see Steph's talk, and Steph's talk covers like the catch section. I've showed you the pitch, right? So the pitch and the catch is kind of covered, and you could see like a full service example of what that looks like. And once you have that, then I think you have all of the pieces that you need from the issuance side, and then you have the verification side that you could then continue to use. But basically, her VC-gated app was really cool because it was asking the user to prove that they were born before 2023 to view, right? So most of you here would be eligible, I hope. But yeah, it was a really good example there. This is the schema, and this is the request. So you basically just request that you say, you make sure that the birthday is less than the start date, like the year that you define. And this is the request that you actually build, and everything else should be easily verifiable on the other side. So Oceans 404 is her GitHub full stack Polygon ID VC-gated dApp, shows you the verification side of things, which I encourage you to look at as you're going through that. And you could scan, so yeah, and once you build with that, you could actually get like a birthday gated. She actually deployed this. I'm not sure it's still live, but yeah, you could scan your code and you go through the whole process. And this is the URL to the verification portion. So if you want to get the verifier side of things, please look at this. And hopefully you could combine the two and win some bounties on Polygon ID. Si, senor. What do you mean, what data?
So what data has verifiers already put on the Polygon ID network? Like if you...
The Polygon ID is not a network. So it's not like we have like a centralized set of like issuers or verifiers or anything of that sort. Anybody could go and deploy their own instance of Polygon ID, which basically ensures that anybody could run this in any way that they actually would like. And it's fully open source. So you have different projects using it in different ways. One of them is like Doc.io, which has a really good integration. If you want to get past the whole headache of like issuance, you could check out Doc.io, and it essentially enables you to be able to issue VCs using Doc.io, or you could use any other system. I'm hoping that answers your question.
Can I ask it a different way?
Sure.
So if you wanted to make like a social network type project, and you wanted to give people like badges based on like certain aspects of themselves they verify, what data is there, like what fields are there to have verified that's already on Spotify?
Okay, so I want you to think of, so wherever you're getting your data source, right? So let's say it's Facebook or Lens, hopefully it's Lens or Farcaster or any other solution. So let's say you're looking at like post frequency, they post 20 times a day, they have connected their accounts to other socials and all those things. So you have a Boolean, you have like a number that defines like the social score or something of that sort, right? When you come into when you're designing your schema, you have full flexibility to define that schema in any way that you like, right? So when I showed you the example earlier, you could actually go in and define your schema to match whatever data that you want, right? In whichever format that makes the most sense to you. Yeah. So in so doing, my schema had two primary fields, which was the Lens follower and your Lens ID, right? So the number of people who are following you on Lens and your Lens ID. Your schema could have those and anything further that you actually define. And once you publish that online, you'll be able to actually reference that information. If you use a schema builder, you'll see it's just like adding fields to a database. And imagine if there is no database, but you actually cryptographically defining a schema that a user could actually provide data against, and the two are then combined to create a cryptographic proof that lives inside of a user's wallet. Does that make sense? If it doesn't, don't worry. I'm around, so you could always like ping me, and hopefully I'll explain it better. Sure.
How does on-chain issuer workflow change from off-chain?
So on-chain issuance is it's a really interesting concept because it allows you to be able to publish like the state of your VC on-chain. And the primary use case is that, let's say you want to be able to, let's say you're issuing like a temporal VC, right? Something that expires. You could actually configure your issuance to be able to publish the state of the validity of your VC on-chain. And part of the whole verification for that particular VC would include a check to see whether or not the VC is still valid on-chain. So that's the main use case, yeah. Anybody else? Okay, I'm sorry. I was actually going to sing, but like I'm out of time, so I'm really sorry, guys. Just going to have to take the talk. Bye.